All right, hello world. This is CS50 on Twitch, and today we're joined by CS50's Nick Wong, who's been a teaching fellow here for a couple of years. And today he's going to teach. Oh, what are you going to teach us today? What are we going to talk about?
So we're going to be talking about binary classifiers using Tensorflow and Keras. And so Tensorflow is actually a project that was developed and built by Google. And I mean, Google has their hands in everything, but TensorFlow is really cool because it basically took the whole linear algebra-ness of machine learning and made it very simple. And then Keras is a wrapper on top of TensorFlow that actually made even that simplification a little bit simpler.
Transition to your awesome little screensaver back here. So, kind of like an introduction to machine learning using some nice open source libraries, some Google-based. Is Keras a Google open source library as well?
I believe so, yeah.
Okay, TensorFlow. I know everyone's heard of TensorFlow,
right?
And, or at least a lot of us have. I know almost nothing about machine learning, so this will be a learning experience for me as well. But I'm super excited to talk about binary classifiers and what they are.
Awesome. So yeah, I'll talk a little bit about the theory first. I won't talk too much on theory. I know people aren't usually huge fans. I like the theory. I think it's really cool. But we're going to just talk about it a little bit to kind of motivate and contextualize what I'm actually going to start saying and coding in front of you. Before I do that, I just wanted to point out this screensaver that I've got going on here. I think it's super cool. I'm a huge fan. It's technically C matrix. That's the actual program that's running. But I put that through another program called lolcat, which is one of my favorite kind of messing with people or troll programs. If you're ever trying to mess with someone, you can display lolcatted stuff.
We'll have a separate stream on how to troll people, how to hack.
It's one of my favorite things.
And this screensaver is in a shell, right?
Right. So this is in a shell. If I press any key, then I'm back in my shell, and I can go back to coding and doing all sorts of cool things. But I like having it there. It's entertaining. It just drains power, so you want to be plugged in.
We have a few comments in the chat there. M. Kloppenberg says, "Hey everybody." Bella Cure says hello. Whipstreak, Bella, and I can't read that last one. Yeah, it looks like Elias. They all say hi, Nick.
Awesome.
So
hello guys. Appreciate it.
We have a lively chat, so we'll definitely read off the messages as we get them in the chat.
Sweet. All right. So. Machine learning. It's one of my favorite buzzwords that everyone throws around, along with blockchain, AI. What's some other one? There's some really good ones out there. Bitcoin, people throw out there.
Bitcoin, massively, those last couple of years.
Everyone keeps throwing them out there, and they're all great. And so I think one of the things that I heard this last summer where I was working, someone said that machine learning is just fancy statistics wrapped up in a computer. And I was kind of like, yeah, not really. I mean, in concept, yes. But not necessarily in the kind of what they actually intended. What they were meaning is you could just use statistics to do the same thing. And when I was walking through kind of our science center today, I was looking at the old punch card style computers. I was like, yeah, technically I can run statistics on that too, but it's different. The game has changed a little bit given our computing power, our memory, and things like that.
A little bit apples and oranges type deal.
Yeah, it was kind of just yeah, you're not wrong really, but you're pretty off. And so machine learning is kind of just a very broad field. It really means just any way in which you get a computer to figure things out. And a lot of it's modeled after how humans learn. So in concept, it's modeled after the way our brains are structured. So a lot of things are called neurons. So you hear a lot of just jargon that gets thrown out. You'll hear tensors, neurons, layers, models, things like that.
I've heard neural nets, for example.
Right, neural network. And those sorts of things can be very intimidating, but they generally have kind of very well-grounded meanings. So for example, a neural net, that just means that like our brain, they took a bunch of kind of individual nodes and they linked them all together, and that's all that it really ends up meaning. Now there's kind of some nuance to that and there's some complexity, but in concept, it's actually pretty straightforward. So what we're going to do is we are technically going to build a neural network today. It is what is required for, or not required, but it's what we're going to use for the binary classification. And that brings us to what binary classifiers are, which is if you have a bunch of data, can I tell you if it's in one of two groups? So it's either going to be group A or group B. And that could mean all sorts of things for us.
So if we're looking at pictures of apples versus pictures of oranges,
is it an
apple
or an orange?
By the way, Darkslayer X says, how often do you stream? So we typically stream, as of the last couple of weeks, this is a fairly new thing, but usually 4 days a week. So Monday, Tuesday, Wednesday, Friday. Thursday is a little bit of a busy day right now for CS50. We're shooting CS50 seminars. You're doing a seminar,
yep,
right?
I will be also doing a seminar.
Do you know what it is on yet?
It'll be on web development with Python and Django.
Okay,
so
awesome.
completely unrelated. Not even related.
But yeah, pretty frequently our goal is to do this roughly 3 to 4 times per week. And it looks like Whipstreak also tossed in that it's on the CS50 Facebook page. Yes, it is on the CS50 Facebook page, most definitely.
The kind of human equivalent of check the man page.
yeah.
One of my favorite responses. That's awesome.
M. Kloppenberg, Django rocks.
Yes, I agree. And we use, I guess, Flask and Flask, Jinja 2, and MySQL in CS50. And I'm a huge fan of Django, which kind of wraps that all together.
Yeah.
But today we'll be just using Python, and we're going to talk about
separate stream. We'll do a separate Django
completely
stream.
different. Yeah, exactly.
By the way, you will be doing another stream coming
Yes.
up on Linux commands. So Nick will do, if anybody's curious on how he got his awesome shell operating this way, we'll dive into the basics of how that sort of works with basic Linux commands.
Yeah, I think that's next Friday, right?
Yeah, next Friday.
Sweet. Yeah, so feel free to tune into that if you think this is cool or if you want to learn more about Linux. All right, so we have binary classifiers. We're just separating things into two categories. And like that sounds like an intuitive thing. If I show you a picture of a square and a picture of a triangle, you'll know that one is not like the other. But for machines, that can be really complex, and actually the theory underneath that seems very difficult. And so machines, early on, that was one of the easiest problems that they could try and tackle solving. And it's still hard. It's not an easy problem, but it is one of the easiest.
Identifying basically like simple shapes.
Right, can I just say, is this or not? Right, so is it a shape or not? Is it dark or not? And so what we're going to actually start with, and for you guys, I actually started a GitHub repository that you guys are welcome to kind of pull code from as we go.
Oh, do you want to let me know what that is, and I'll type it in the chat?
Yeah, so it's at github.com/powerhouse of the cell.
Let me get the. Sorry, I can't read it too well. Powerhouse of. Oh, you're right. Yeah. Literally. You changed your Twitch handle a little bit.
Last time. I had to change that.
Is _ real.
Yeah, exactly. So our eventual goal for today, what we will get to by the end, is given pictures of kind of cartoon people versus real pictures, like a portrait, can we distinguish which one was real? Can I tell us, is something cartoon or is it not? And the reason I thought that was really cool is there's no necessarily apparent programmatic way to distinguish the two, right? You can't tell based on color. You can't necessarily tell based on like orientation or type of shape. Maybe for like really bad approximations in cartoon structure, you could maybe guess at that, but even then, that might not be true.
I was gonna say if I were to take an initial stab at it completely naively, I would probably build the cartoon classifier, and then work my way up to real humans, because I feel like that's kind of it's almost like a simplification or an abstraction of that.
Right, exactly. And so that's kind of what the what my point was, is that even given very limited tools, we have basically no theory that we've talked about. We don't have to talk about likelihood maximization or any sort of like summation notation, none of that. We can still do that. We can get really high accuracies with pretty minimal tools. And they're all open source. They're all available anywhere you want to go. So I think that's really cool. And I think when I was beginning CS, that was super inspiring to me. So I like sharing that with people.
Cool.
We're also going to use a third library I kind of forgot to mention. It's called OpenCV, or Open Computer Vision. I think it was UC Irvine's project. And I actually used that my freshman year, but I've kind of used it ever since because it is one of the primary libraries for like reading images, for just kind of pulling them in and doing stuff like that. But the problem with OpenCV is they update their documentation possibly less consistently than college kids go to sleep. Like it's just, it's so all over the place. It does say MIT license. To respond to Whipstreak's question, which is it an MIT license in my GitHub? Why isn't this Harvard? MIT license is actually kind of a broad license. It's generally used for like kind of personal projects or projects that you want to be able to share with the world, but you do want them to kind of acknowledge you or kind of just reference the fact that it's not necessarily theirs. It's one of my favorite licenses to use on GitHub. Another common one that you might see is like the GNU license, as well as the Apache license. Those three are pretty well known. And then there's a bunch of other license options that I don't understand super well.
And then Fernando also says hi. Hi, Fernando. Thanks for joining us today.
Awesome. So we're going to get going a little bit on kind of our environment and what we're doing and how we actually go. So I'm in Bash. This is kind of my command prompt. I just like the color blue a lot. Ironically, I'm wearing red, but that's okay. And so this is my Bash prompt. If you're not super familiar with Bash or Linux shell, don't worry. I might refer to it with a couple of words like terminal, console, bash, shell. They all mean the same thing. I just mean here. I can type stuff like ls, which has all sorts of stuff on there. I'm a mess. I can do like ps to see what's actually running, very little. There's a bunch of other commands, and we'll go into them next Friday. But what I'm going to do is I actually have a technology called virtual env wrapper. And what that means is I can basically create these kind of separate little Python modules, kind of Python environments for myself. And so that means that if I have some project that uses, Python 2.5, and then my current project uses Python 3.7 because I'm not in the 20th century, Sorry, I like to jab at the old Pythons. Then I can separate everything out and not worry about colliding dependencies or colliding version numbers. I can keep everything very clean.
Or even like two versions of the same library.
Exactly, which would be, that is the worst. I have done that many times and it's awful. So we're going to call that this version, is it real? It'll match with my GitHub and I'll try to be very consistent. And you'll see that when I run this, make virtual env I'm not really necessarily going to go into. There are a lot of tutorials online on how to install a virtual env wrapper. That is what I'm using though. And it takes a little bit to go, but it creates all these ways for me to actually interact with Python kind of in an isolated place. And you'll notice that over here, it puts a little, it prepends a part to my prompt that says that I'm in that virtual environment at any one time. So I can leave it by just saying deactivate, just for those of you that are going, and then I can work on it using this command. Cool. So I'm also going to create a folder for this. I normally would have done like some make directory or mkdir, but I'm actually going to just go into the one that it's called Is It Real? My apologies. I'm going to go into one that I already created just because I already cloned my GitHub repository. If you cloned it, then you'll actually end up being in a place like this, and you'll have these two files in there. It's just the README and the license. We are literally creating this from scratch. So I apologize if we have some syntax errors, and you'll get to see some really live debugging.
We've had plenty of that on the ones that I've done. So
that's good to hear, because there's going to be plenty on my end. All right, cool. So we're in a Python virtual environment, and we need to pick up a bunch of packages. So we're going to do that live too, which never goes well. I've never had this go correct on the first go. So we're going to pick up some kind of maybe not conventional ones, or they aren't the names of the packages that I said at the very beginning. We're picking numpy and scipy. Those are very common, like machine learning, any sort of numbers or data analysis. You're going to usually see those. Numpy makes things very fast, generally speaking, and it's going to give you a bunch of operations with numbers. I'm going to actually let this run while I talk. Oh, good, they're cached, thank God. They're kind of large, so they're kind of a pain. And then scipy is a bunch of like science-like tools, so if you're analyzing data, it's really useful.
It's literally in the name.
Yeah, it's almost like Python is super intuitive. It's meant to be user-friendly. The next one that we're going to grab, and I always forget what it's called. I think it's OpenCV-Python. Their package name is not super intuitive, because the package itself, when you import it, thank God, is called CV2. However, we're using CV3. And it's still called CV2, so there's that. And you download it as OpenCV-Python, which is absurd. So I don't really like their naming scheme, but that's okay.
Whipchick says Nick and Colton are acting like best friends. Are they? We're definitely good friends. We taught a games course together, actually. So we do have a little bit of history here.
Yeah, Colton's awesome. I actually got to watch him full powerhouse last year, teaching his course that he kind of went and did the whole 9 yards on. I was just there for the ride.
We flipped the situation around a little bit, so now you are teaching and I am observing.
I appreciate it.
It's fun. It all comes around.
Yeah.
Twitch Hello World. I don't see the live stream video. Is everyone seeing a live stream video? The video should definitely be up. I see it on my Twitch. Definitely refresh the page and see if that fixes it.
Very possible.
Asley, who's Nuanda3333, says, hi everyone. Yes, Twitch Hello World. Good to see you, Asley. But yeah, if you have any issues, definitely refresh the page. I'm seeing it live. It looks like everyone else is seeing it live as well.
Yeah, good luck. Debugging browser stuff is one of my least favorite tasks. That's why I work in Python. All right, so let's see. We've picked up numpy, scipy, OpenCV. We also need pillow, which is not an intuitive package that you would want. It's capitalized too, so just in case you encounter some weird errors there. And pillow it's the, Python image library. So that translates to pill. Yeah. They call it pillow, and it's capitalized, but when you import it, you don't. You don't import pillow anywhere, really. Some of these packages are kind of absurd. So then we're also going to install the kind of stars of our show, which are TensorFlow. So kind of shout out to Google for making that accessible to everybody. And Karis, which is a wrapper on top of TensorFlow. It makes it a little bit higher level. It's a little bit easier to interact with. And that way you're not dealing with as much terminology, so you're not sitting there being like, what's a tensor? What are the dimensions? And all these things.
Shout out to also how easy it is to install all these packages. That's probably why Python is so successful.
Gotta love Python. I'm a huge fan of Python. I think Colton is too. Python is just very well done. You're seeing kind of maybe a different output than you might see on your screen because I have used these packages pretty extensively, so they're all cached on my machine. Just means that they've kind of been saved before, and you'll see some like bars that go across, and that should be correct. Cool. Cool. So we've downloaded all of our packages. If we wanted to test that out, we could go into the Python REPL by just typing Python and say like import TensorFlow, and that should not fail. That would suck if it did. And like maybe from keras.models import. Yeah, I think that's probably right. Import model. I'm also going to assume a lot of Python syntax, so if you have any questions, feel free to post it in the chat, and we'll be happy to answer it. And so yeah, we have both TensorFlow and Keras. And then the last one that we want to double check that we have is CV2.
It looks like Karis even has like a implicit dependency on TensorFlow.
Yes.
It looks like with that line there.
Yeah, exactly. So actually, Karis has this thing. I think most people use TensorFlow now underneath it. It's kind of the backend for it, but it can also use Theano, which is a different machine learning background or backend. It's very cool, also very powerful. I just happen to use TensorFlow. So you can use either one. We're going to just talk about TensorFlow though. Cool. So we can exit out of that with Control D or by typing the word exit and parentheses. And now we're going to actually start kind of creating some code or writing some code. So what I'm going to do is, generally speaking, I like to kind of separate things out and be very modular and have good practices. But when I first go through stuff, I just want to get it working. I just want things to actually function correctly. So we're going to write kind of a monolithic style for this, meaning that basically we're going to, and actually I'm going to just touch this. Oops, can't spell. Can never spell live. And we're going to just touch run.py. I like calling it run.py. It kind of indicates what I'm going to do with it. I'm going to run it. And so that makes things a little bit easier on ourselves, and it'll be a little bit easier to follow so that we're not flipping between files all over the place. However, I also don't exactly love typing in just bash and using nano for everything. So we're going to use Visual Studio Code. It's one of my favorite IDEs. It's completely different team was behind it, or I think mostly different team was behind it at Microsoft than the team behind Visual Studio. So if you have any kind of like gripe with Visual Studio, one, they've revamped it a lot, but two, it's very different from VSC, and VSC is super customizable, has a lot of nice plugins.
Big fan of it myself.
Yeah, which is nice.
A couple comments there. Looks like Whipstreak says, what is the machine learning program's objective?
Okay. Right. I didn't actually mention it. I mentioned it to Colton right beforehand and then didn't actually, I think, say it. So we're going to be going over, basically the end goal is to see if we can distinguish, given an image, if it's a cartoon image or a real life one. And we're going to focus kind of on images of people because that makes it a little bit easier for us. But that's going to be the end goal. We're going to start with a little bit easier of a task, which is distinguishing whether or not an image is dark or light, because I think that kind of conceptually is a little bit easier for us to understand. Right. Like there is a way for us to figure that out, right? I think you could maybe, upon kind of thinking about it for a little bit, come up with a program that does it deterministically. Takes like the average, images are just data, and it maybe takes the average over all the images kind of intensities and says if they're over some threshold, it's light, and if they're under that threshold, it's dark. And I think that would be kind of a very nice like programmatic way to do it. You need to adjust a mic. Yeah. My apologies. Thank you. No worries.
Dan Coffee, everybody. Shout out to Dan Coffee.
Makes all of this magic much more possible.
We got some other comments there too.
Yeah.
Chitsutode, hi there. What's the topic today? Machine learning. Yep, machine learning. Going to be talking about TensorFlow and cartoons, light and dark. Oh, David J. Malin's in the chat.
Wow, that's
Everybody,
awesome.
shout out to David J. Malin, giving the the VS Code link there.
Yes.
Coming in the clutch.
Very helpful.
Lots of hellos for David there. Magus503.
Nice. Yeah, I love it. Is that a unicorn image?
I think so.
Or maybe a pig?
I think it's a brony, maybe.
Oh, brony. Nice.
I can't tell. It's hard.
Yeah.
It's hard to tell.
It's something. It's cool.
If I log in on a desktop, says Twitch Hello World, and is it maybe an option to see the live stream video there? I would use Chrome. Use Google Chrome, because that's the only web browser that I've really tested this extensively on. It should work in Firefox, should work in Safari, should work on most major web browsers, but the latest version of Chrome on twitch.tv/CS50TV should work just fine, so give that a try.
Yeah,
I'm not too familiar with any Twitch for desktop apps, but presumably those would work as well, but Chrome is the only one that I'm personally familiar with.
Makes sense, yeah. Yeah, actually same. I usually don't watch too many Twitch streams, actually.
Just star in them,
yeah. I like to just kind of host them. All right, cool. So we have kind of this open. If you're not super familiar with an IDE, don't worry. On the left, you just kind of have my file structure, all the files that I have access to in this kind of directory. At the bottom, I have a console. So this is just bash again. You can just list things out and do normal bash things. And then in the kind of main bulk of the screen is where we'll actually be writing code. Hopefully that's not too small for everyone. It should be big enough that everyone can read it.
I think that's the size I usually program on.
Okay, perfect.
If anybody thinks it's too small, definitely let us know in the chat.
Yes. And actually, I just moved my files off the screen, give us a little bit more real estate. So what we're going to do is we're going to kind of set up all of our imports and kind of get this file built so that we can actually run it and execute things that are going on. I know just kind of ahead of time I'm going to need OS. I'm going to use it for like path joining and checking directories and things because we're going to have pictures in a bunch of directories. So I'm going to use OS for that. I also know that I'm probably going to want argparse for kind of later design stuff. Argparse is just a really convenient library for doing command line arguments, so I don't have to do like if the length of argc, or if argc is greater than 2, then this, and then otherwise. I just particularly like argparse. It's built into Python. And those are kind of our two system libraries, or the built-ins for Python. We're also going to definitely need Karis. But with Karis, you don't usually directly import Karis. We don't actually need Karis on its own. So we're actually going to say from Karis.models import sequential, which is not exactly model. It's actually, I think, a subclass of model. And sequential has a bunch of things kind of preset for us because we know that we're going to be building some form of model where we just kind of add layers to it one at a time. And actually, we may not have known that. I know that, and I'm going to tell you that is how it's going to work. And so, yeah, sequential model means that we're going to just kind of stack everything together. It looks, if you were to kind of view it in real life, it would literally be a stack of layers. And each of those layers represents all sorts of different things. And we'll talk about those when we get there.
That's like refinements, possibly?
Yeah, exactly. They're ways of kind of tinkering with the data as it comes through. I like to think of it as like, if you imagine them as a bunch of filters and you're just kind of pouring sand through it, and at the end you get something meaningful. Hopefully sand you like, yeah, or like a gem. Cool, so we're going to import Karis. We're also going to import, CV2. And that is going to just let us open images and do things, basically all image manipulation through that. And I don't think we necessarily need any other ones. Oh, we actually do also want numpy. We're going to use it to kind of reshape arrays and images and things like that. And so numpy actually usually gets imported as something. Usually, the convention seems to be import numpy as np. And so a lot of tutorials, you'll see just np dot blah, 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 and that kind of assumes that we'll use np. Cool. And then I like to kind of follow the C paradigm of if name, yeah, you're going to see me mistype constantly today. Then we're going to run stuff. And I'm going to put pass there for now, but we will generally put something there. And I like to use this space up here to kind of write out some functions and kind of help with debugging. And then down here, we're going to kind of just call those functions. So a very kind of C script mashup is what we're seeing here. However, I also like to use Control-C to exit out of functionality as we go. So I'm going to wrap this and try and accept. Keyboard interrupt. And that'll let me just say, like, oh, the user deliberately aborted. I like to preface that. And that'll just make it a little bit easier for me to distinguish between me Control-C'ing and actual errors that happened while we were running. So this is one of my favorite ways of setting up programs. You're welcome to do your own. Excuse me. All right, so before we actually even get to the Karis.models import sequential, I'm going to let us have access to command line arguments in case we get to that later. So I'm going to say AP, just stands for argparse, is argparse. I was doing this without a editor earlier when I was kind of testing things out. And man, it's much harder. This is great because I just have like autocomplete and I don't have to remember the actual names of things.
IntelliSense.
Right, IntelliSense. What a beautifully built thing. And then I'm going to just say that this is ap.parseArgs. Sorry, I didn't really narrate any of that. In between this line 4 and line 6, we can put like ap.addArgument, and those will be available to us on the command line. So that's just a really convenient way of doing this. And actually, even right now, there are certain commands that are now available to us on the command line. So we're going to kind of look at that. If I do run.py, it'll tell us that we're using TensorFlow, and nothing will happen. That's what we expect. But then from here, I can actually do -h, and we'll get kind of a usage message, and that's argparse doing its job. And the reason that I do that before TensorFlow, or before kind of importing Karis, is because Karis is actually a very slow import. So we're completely able to kind of ignore that if someone didn't pass like a necessary command line argument, or they wanted to just get help. It speeds things up just a little bit. So maybe stylistically looks a little strange, but it's definitely not too problematic.
I think Whipcheck has a question for
you. Oh, yes. In line 12 and line 13 necessary, or sorry, 16 and 17, I believe you're talking about this. You can also use like the actual code that's in those lines, because lines will kind of change and we're a little bit delayed, or you guys, I guess, are a little bit delayed from what we perceive. So also telling us which lines of code you're talking about.
I think he's
by
asking,
name.
or he or she is asking, whether the if name is main is necessary to run the script.
Okay, I see. No, so if you're asking about the if name equals main, then we do stuff. It's totally not necessary. Python is a fully capable scripting language. You can just run Python scripts as you go. I just like to kind of follow a C style paradigm where we have a main and it actually gets called and things go. This also means what also ends up happening for us is that if I import this whole file as a module, then that stuff is not going to get automatically run. So I would have I would have access to the functions that I might build earlier on or later in this file, but I'm not necessarily going to like have them all just run without me telling them to. So it kind of serves a couple of purposes. I think it's very convenient. Cool. So now we're going to start building some stuff. So you might say, okay, well, the first intuitive thing is that we're going to want to be able to load data. And that makes a lot of sense, except I don't know what my data looks like. I don't know where we got it from. There's no data that exists at the moment, and I have no file structure for it. So loading data is kind of unimplementable at the moment. And I like to kind of walk through these and kind of motivate different parts of the problem as we go. And we've now motivated that we don't have any data. To run a machine learning model without data is, I think, a nonsense idea. So we're going to get some data. You're going to get a nice view of just how messy everything is in my file structure. I'm going to use Finder to kind of just create some files. If you will trust me on faith, you can hopefully believe that this is the same directory that we're looking at here, and it's the same directory we're in over here. They're all the same. And if you don't believe me, then I don't know. I apologize. Nothing I can do on that. I'm going to call this images because our data type is images. You can call it whatever you'd like. And then within image, I'm going to actually have 3 folders. So the first 2 are train and test, or validate is another word that you might use for that. And this is pretty standard in any sort of like machine learning setup, at least for supervised learning, where we're trying to feed it answers and get it to learn some pattern, is we're going to say, take my data and split it into 2 data sets. I have a training data set and I have a testing data set that validates whether or not that data is good. And the reason that you would split something is in machine learning models, they can sometimes overlearn things. For example, humans do this all the time too, where I might tell a child that, you know, after 1 comes 2 and after 2 comes 3. And the child might then go and say, okay, well, then after 3 comes 4, and then 4 comes 5. And that's very reasonable. That's something that's totally what we might expect. Except I might have just fed you the first couple of numbers in a Fibonacci sequence, in which case after 3 does not come 4, but rather 5, and then 8, and then 13. And so it's really important to us to be able to give the machine learning model data that it doesn't incorporate into what it actually does, and data that it can then just see how well it actually is doing. It's called overfitting, where a machine learning model learns all of its training data by memorizing. And so it just says, this is what I know, this is everything that I'm going to do. An analogy for that is a child saying, you know, I know 4 colors and I know them very well. And then you hand them a new color and they have no clue what it is. And that's something that real humans could, in concept, do. We tend to kind of compensate for that, but it's definitely very possible, and machines do it all the time. So we split this into training data to give it something to actually learn on, and then we see how well it's actually doing kind of in like the real world on data it's never seen before in the testing data. And that data does not get incorporated back into how the machine actually learns. It's kind of just used literally to test it. And then the third directory that we're going to put in is a predict directory. And I just like to kind of structure things really cleanly. And so this directory is just going to contain a bunch of images that I want the machine to predict on. I want the machine to tell me, what do those images actually have? Are they light? Are they dark? Are they cartoon? Are they real? Things like that. Cool. So in train and test, we're going to want, the way that Karis kind of pulls images from a directory is it uses the directory name as the label for that data. So I'm going to create a new folder, and we're going to call that light. And I'm going to create a new folder here and call that dark. And so we'll want to replicate these over to test. And so these 2 folders, basically what they do is inside of dark, I'm going to put a bunch of dark images. Not dark in the kind of metaphysical sense, but literally just darker images. They're just like blacker colored.
R-rated stream.
Yeah, we're going to keep everything very nice and PG, I hope. And so everything here will just be, is it literally just more black pixels or more light pixels? And a lot of times people are like, oh, you know, I have to collect a bunch of data. And I've actually been very much an advocate of collecting just smarter data, not necessarily more. So what I mean by that is, are you covering all the cases, for example? And in our case, we don't really have that many, right? There's just like well, actually, I guess there's a very large number of ways you can make a dark image versus a light image. But what I mean by that is we can collect some things like maybe there's a just pure black screen. Okay, well, that makes sense. And that's dark for sure. But what about if you had a black screen with some stars in it? Well, then that might actually be slightly different. Or for example, this picture, I'm literally going to just drag and drop a bunch of pictures from Google. This picture, I would classify it as dark. It's pretty black. There's like a little candle in there. And so a machine might not deterministically be able to say, oh, well, that's dark. But machine learning can probably figure that out. And so I'm going to copy a bunch of these images. You'll notice a lot of them are not exactly all black. Most of them have some sort of image in them. And this one is pure black. Love that. This one is also quite dark, but not black really. Not as black as the other ones.
An interesting test case on that one, yeah.
Right. So I think that that's something that would be really worth putting in front of our computer. And I'm kind of deliberately ignoring an image that I know is on the right because it's a really good test example. So I'm going to grab 10 of these. Oh, sorry, it's actually down here now. So there's this image. And this image I would classify as dark, but it has a very bright center to it. So if we can get our machine learning model to figure out whether or not that's light or dark, that'd be really interesting for us. So we're going to put that in kind of our predict folder. So
Zodiac
we know.
says, hey guys, I'm Wesley Zodiac.
Oh.
Good to have you, Wesley. Thanks for joining us. And then Bavik Knight, who's a regular, is in the chat. Says, hey guys, seems like I'm very late today. No worries, Bavik. We're just getting started. So, and the code is on GitHub. I'll try to post that URL again.
And at basically every major point, I will push all of the code that we have so far to GitHub. And I guess if you were around last week, they actually did a whole stream on GitHub and how this
with
very powerful
Kareem.
tool.
Yeah, on Twitch and on YouTube, we do have a Git and GitHub stream with Kareem Zidane. Kareem the Dream.
Kareem the Dream. All right, and then I'm going to just switch over to our testing folder and put some other dark images in there. This will let us get a good gauge of just whether or not we're kind of accurately measuring things. I think in the previous folder for training, I put about 10 images for testing data. Oh, Black Mirror, what a fitting, very appropriate thing to test on. I had put about 5. There's not really a hard number on how many of anything you should have, but I generally try to go for nice numbers that I think are really cool, like 5, 10, and 42. I think the more data you get in general, you can do better, as long as your data brings up new patterns. So then we're going to just kind of bring in some more images. Sorry, this part is not particularly interesting. I'm not writing any code.
Hey, it's from scratch. The whole thing
is from scratch. So you could literally follow along click by click, and you will technically do this.
Or choose their own images even.
Yeah, you could even pick your own images. This is meant to be as generalizable as I hope possible. And so we're just picking up very light colored. Oh, sorry, I picked up a few too many. I like to keep my data sets balanced. So if I have 10 in dark, I'm going to try and keep 10 in light. I am a little, weirdly enough, you wouldn't believe this by looking at my desktop, I do like to keep things kind of organized when I code. I think when I organize my life, not so much.
People have different definitions of organized, It's
it's a flexible definition. So yeah, I'm very organized when I write code. I'm not necessarily so organized when I do the rest of my life. Cool, so then I'm going to kind of rename these. I just think it's a little bit cleaner to have this, and then we're going to get some light testing data. I think this is just such a pretty picture.
Oh yeah, that's a nice picture.
Very cool. We got it. I thought it was a unicorn. I was super excited for a second. I thought it was a unicorn.
Can you explain again what the difference between the test and the what was the other category?
Yeah, so we have test and training data.
Yeah.
And there's also a predict.
Predict, that's what the test and predict. What's the difference between those two?
All right, so testing data is going to be said at every step that we run our machine learning model. We'll see how it did on testing data. That won't be incorporated into the model, but it'll tell us how are we actually doing? Because on its training data, it'll generally go up as it starts to just memorize things. So we want to see on data it's never seen before, is it actually getting better? Are we actually seeing some improvement, or are we kind of at a loss here? And so we'll see a little bit clearer what exactly I'm talking about when we actually start to run some models. But basically, the testing data shows us how are we actually doing. The training data we generally should improve at. If you're staying at kind of just this flat 50-50, you're probably doing something wrong in your model. In fact, there is an error I discovered earlier that I think would be really good for me to show everyone that I like to mess up. Cool, and then we have 2 images. Oh, and predict, sorry, I didn't answer that part. The predicting data is after we've trained our model, we have it kind of thinking, and it thinks it knows what it's talking about. Then we're going to test it on data that it doesn't really get thrown into any sort of framework. This is really kind of the use case of our model. So if I wanted to use it for like actively predicting things, then we're going to say, hey, let's take a look at how we might do that. So it might not be in the directory predict. We might even pass it as like a command line argument. It just goes and finds it.
Okay.
But I like to keep it organized there for now while we're going and developing.
Makes sense.
Cool. So we have a bunch of images. They are just, I guess, for the sake of copyright, they are not mine. I literally pulled them off of Google. You watched me do that. They are in no way my images, and I certainly do not take credit for them. I only take credit for knowing how to Google, or barely. And so we just went and found some random images. And if you don't believe that those are the same thing, here are all of my same directories that we just built. I just used Finder because I think it's a slightly easier interface. Cool. So we have all these images now. Let's see if we can go find them. So when we say load data, that means that somehow I have to get the images that I just kind of put everywhere and return them to me as test and training data. So we're going to go and get some of that data. I'm probably going to be given an image directory or image dir. And I probably want to go and maybe enumerate what's in that image directory. I happen to know that the structure of this directory is in a kind of test and train split. So what we might do is I might say, okay, then my test, or we'll start with train images, we'll say paths. And so I will probably switch these to abbreviated versions because I think those are conventional. So this is our training data, and these are the image paths that we get. I'm going to use a list comprehension because it's convenient, but if you are not comfortable with those, then I think it's somewhat easy to flip this into a for loop. Hopefully not a problem. If you have any questions on syntax and things, then feel free to let me know. If you spot any bugs, maybe just kind of like chuckle to yourself and you'll see me find it later when I try to run it. Cool. So what we want to do is we're going to do like os.path.join, which is a cool command. It lets you just actually join paths together without really having to worry about like slashes and things and double slashes. And I know that this is going to be in my training directory. And then I'm going to just do like image path. And this is for image path in os. Okay, this is possibly very poorly styled code. It's going to be a very long line. We could have split this up. For in os.lister, os.path.join. Oh man, that maybe was not the best planning. That's okay.
The beauty of list comprehensions.
Gotta love list comprehensions.
At least you can enter in the middle of it though to break it up, which is nice.
That is true. Yeah. Well, actually, that's a very good point. We might do that. So technically what we are doing is we're taking the variable train image paths. We're setting it list equal to this list. I've realized I'm starting to skip words. That's kind of cool. And so what we're doing is we're saying join the paths of the image directory we were handed, the training directory, which we know will exist. We're hard coding that for now. And then the image path. And the image path is given to us by iterating through and assigning, as we go through, image path to each of the things or items in this list. And this list is a list of the directory, which is given by, again, joining our image directory and train. So what that basically ends up meaning is that we're going to go and collect all the paths of things that we went and put into our image training directory. And then you really should never copy and paste code, hashtag CS51. We're going to copy and paste code, and we're going to change some variables. Gotta love that. And we're going to say, okay, here's my test image path, and this is also in test. Yeah, live coding will really test your ability to like be confident in what you're doing. All right, so I generally like to kind of iteratively debug things. I don't like doing huge monolithic swaths of what's going on. So we're going to just run this in our script. So we're going to have load data, and we're going to say image is the data directory. We might pass that in as like a command line argument later, and that might kind of trigger some bells. But now we should be able to run this, and it should print out to me both of the things that contain our image data. So then the thing that we have in here is you'll notice that there's like this .ds store. That causes some bugs sometimes. It won't cause bugs in this case because Karis ignores it when it's like flowing things from directory. But if you try to load individual images, that does mess with you. So just kind of keep that in the back, very far back of your mind. It is something to keep in mind. All right, so now we're going to get into, the kind of meat of Karis. And unfortunately, I don't remember the exact syntax off the top of my head, but I'll tell you what we're going to go do, and then we're going to do what every CS person should be very good at. We're going to look at some documentation. We're going to remember what that name is. So I have these paths now. I know exactly where all of the images are named. I actually don't necessarily need each of their paths. I really only need kind of this os.path.join of here. That's the actual directory, and we're going to use that later. But I like to have the image paths for kind of displaying which images we're actually looking at later. So it's kind of just a future thought-focused thing. But we're going to do what Karis has beautifully built, which is called a flow from directory. And the reason that we're going to do that is because we don't necessarily have a lot of data. And our data is certainly incomplete. There's plenty of ways to make another dark image. But the reason that I think a flow from directory is brilliant is because it allows us to take our small data set and make it into a very large one. Because an image that looks like this, if I were to flip it around, to the computer, that's a different image. But to us, for our purposes, it's identical. It's still dark. It doesn't change anything about it. So what's beautiful about Karis's flow from directory is it kind of randomly does that. It'll start flipping images. It might cut them in half. It can flip them around in all sorts of directions. It can shrink them. It can resize them however it would like. And it allows us to kind of create data from just our existing data set. We don't have to go out and find any more.
That's cool.
So it's a very cool feature.
Debug says, we don't have a main, have we?
We kind of do. So what Python actually ends up doing in kind of a nutshell is if the Python script is run as a script from the command line, then it is going to have main. But if it's run as like a module, it's imported as a module, then its name, this variable that we never really instantiated, is not going to be main. I actually don't know what it is if you run it as a module. But yeah, no worries there. Let's see. Am I supposed to log in? Twitch Hello World says, am I supposed to log into GitHub to see the code at the URL? You don't need to log in. It is a public repository. There is no code there currently. After we load all of our data in, I'll push that to GitHub so that everyone can kind of see what's going on there. Cool. So we have Karis. Their documentation got updated. I say recently, I mean within like the past 5 months or so, which I'm really happy about because for a little bit there it was a little confusing. And I know that down at the bottom they do this whole thing talking about image preprocessing. And there's just a bunch of stuff that that I happen to kind of know by reading through this. I know that I'm going to want to do some sort of actual generator. But this is not the exact one I want. This one is. So this little bit of code that is in the Karis documentation, I take no credit for writing it, is basically what we're looking for. This gives us the ability to do our data generators, which are kind of that whole applying random operations to our data set. And then we do these actual generators, which are going to be the flowing from directory. It's going to pull all our data into some sort of directory, or from the directories that we listed, and it's going to do stuff with them. We're going to do stuff with it. So I am going to literally copy and paste this code. Not necessarily the best model, I think, for doing things, but
true from scratch programming today.
This really is from scratch programming. I mean, I did actually walk through this with myself a little bit last night, but I deleted all of that code so that you would get a legitimate version of this, and you would see that there is a lot of effort and thought and messiness that goes into this. So we'll notice that in VSC, image data generator is highlighted because it doesn't exist. We'll deal with that in a second. It's just an import that we need. I'm not a huge fan of their style. I prefer this one, but that's okay. So in this train data gen, we know that Rescale basically, sorry, I'll keep saying we know, I apologize. I mean just Rescale is going to allow us to reshape the image's just size. It's literally like taking the image and just shrinking it this way or that way. Shear range is not something we're going to actually deal with, though it would be totally valid. And that takes an image and just kind of, you can think of it as just kind of cuts off parts of it. And that's definitely a useful operation for us, but not necessarily in this case. I don't necessarily need zoom range. I think there's one called vertical flip. And so vertical and horizontal flips do exactly what they sound like. They flip the data. And we're going to use this for now. So it allows you to rescale stuff to grayscale for this. Allows you to do all sorts of rescaling here, as well as rescaling the image size. I should actually double check on what rescale does. That's okay. We'll look at it in a second. But then horizontal flipping and vertical flipping allows us to create a bunch of new data, a little bit of new data, where you can do a horizontal flip, you can do a vertical flip, or you can do both. And those will create kind of new images for the computer. And then this test data gen is going to just be like our testing data. So it's the same kind of thing, but for the test data that's going to be used to validate our model. And this one has only the rescaling factor. Cool. So then we get into the generator, and so this is where you see this flow from directory. It's one of my, I think, my favorite command that Karis has because it allows you to do this extra data creation. We are actually, this happens to be for a binary classifier. Cool, so it's still going to be a binary classifier. And you'll notice that there's this thing called target size, and then there's this data directory. So we are going to change those two things. So I'm going to just kind of copy a little bit of what I had above. And that's my training directory, is just os.path.join of this, which is our image directory that we supplied via the argument, and the testing directory, which is just called test. And we now have two directories which hopefully have two folders within them that have a bunch of images in them. That's what Karis expects. And then this target size is the size of the image. It kind of assumes that they're of any dimensionality. We rescaled them so that they are only two-dimensional images. Color images are actually in 3 dimensions, right? We have kind of our height or width and our height, and then we have our colors, right? We have R, G, and B. If you've been doing CS50 stuff, you actually know exactly how that works, probably very well. And so I'm going to change our target size a little bit to be 500 by 500. They don't have to be squares. I just think it's kind of cool, and it won't really matter for us, right? A dark image that has been reshaped and kind of distorted but is still kind of all the same pixels is identical to us for these purposes as the image that's in its original size. And then our batch size, and this actually has too few parameters. I'm going to add a few. Our batch size, let's say, is just kind of a nice clean round number. And then so batch size meaning how many images does it pull for any given step within the process. And then I don't think we need anything else from this except knowing where exactly that came from. And if you look on their documentation, they do list all of the possible ways in which you could manipulate the data before it comes in. There's some really cool ones. Fill mode I think is actually really nifty. And that basically just inputs some data for you if you need it to kind of fill out images that aren't all the same size. It allows you to kind of, instead of shrinking them or expanding them, it lets you just fill in the extra space to the kind of maximum image size. This is the actual split between the two, so it reserves some fraction of things for validation. So if you just had training data, then you could split some of them to be only validation data. And there's some other stuff that goes into this. But we have this image data generator class, and you'll notice that it seems to come from here. That's kind of the full module path. So what we're going to do is I'm going to copy that, and we're going to paste that here. From keras.preprocessing.image, import image data generator. And that's how I would convert those kind of full paths to hopefully what actually does its job. We'll see if that's true. That's the intuition, at least. And you'll notice this actually went away because IntelliSense thinks that I've at least done it correctly. Hopefully it's right. And then the rest of this we're going to kind of leave on its own. So we have our validation, or our train generator and our validation generator, and those are going to be what our model actually ends up getting fitted to and trained on. Trained on and fitted to are actually pretty much synonyms in this sense. So we have our train generator, and I'm also going to return the validation generator. Cool. So we've loaded our data, and hopefully we end up actually getting data. I'm also going to now accept those arguments. I'm going to call it train data and test data to be consistent with myself. From the way that I labeled my directories. You're welcome to change those variable names. I think that would count as kind of like some sort of consistency points. And we're going to run this and make sure that nothing happens. That's literally what we want. We want it to tell us the images it found and do nothing else. And that's exactly what it did. And so I'm very glad that that's what it did. And also that is exactly what we were expecting, where it found 20 images belonging to 2 classes. So you might intuit, oh, that was our training data set, which is good because that was the one we ran first. So I'm glad that it came out first. And then it found 10 images also belonging to 2 classes. We're still doing binary. We got 2 classes and 10 images. We know that that was our testing data. So everything seems to check out. And hey, we're still using TensorFlow. So I'm going to kind of git add. I am in the habit of saying git add dot. Not a great habit. I'll git add image and I'll git add run.py.
I'm in the same bad habit as well.
It's a terrible habit. Someone in our CS61 class actually committed the entire subversion tree of it was like some Unix command. Like they accidentally pulled an entire Unix subversion tree into it.
Probably not what they intended to do.
Was certainly not what they intended to do. They actually crashed our grading server, which was
nice.
really kind of cute. Everyone was like freaking out. They were all like, "Oh no, I can't get my grades in. I'm gonna fail." And yeah, the professors are like, "Oh, we'll just extend the deadline. It's fine." All right, cool. So that has now been pitched to the GitHub. So if you would like to grab it, you're welcome to pull that up. Can anyone? Sorry, is that Neo Chris?
Neo Chris. It's hard to pronounce that name. I'm not sure.
I do not know how to pronounce your name. I'm so sorry, but I'm going to call you Neo for now. And if that offends you, please let me know. So Neo asked, can anyone tell me, is there a link for C++ and JavaScript Harvard video lectures / sections if there are any? I don't necessarily know for my other classes. I know CS50 has some great videos on JavaScript. I don't believe we have any on C++.
Yeah, CS50 doesn't do any. Hasn't done any C++.
Yeah.
We have done some JavaScript videos in the past, and Brian Yu's web course, I believe, goes into some JavaScript. If you want to go to that URL. For some JavaScript stuff, but yeah, no C++ yet. We'll keep it in mind for maybe some future stream videos.
Yeah. Yeah, no, I think that would be very fun to go through. C++ is a great language. It does all sorts of cool things. JavaScript I have a lot of beef with, but it is technically a very useful language. I think it does a lot of very strange things. And actually, speaking of JavaScript, TensorFlow, which is the kind of back end of what we're doing here, was recently implemented in JavaScript. By Google, and so they released that, and they have all sorts of really cool demonstrations on using machine learning on the web browser. So that's actually what my winter break will probably consist of, and I'm super excited for that.
That and the WebAssembly.
Yes,
that'll be huge.
WebAssembly I think is a huge just advancement of browser technology. I'm super excited for that too.
It feels like the
so
two
many
go
cool
hand in
things.
hand.
I think so. I think that will actually vastly improve the kind of abilities of what we see browsers doing, which, given Spectre and Meltdown, makes me a little bit nervous. I don't know if I want my browser to be able to do a lot more than it already can, but I think it'll be cool as we work out kinks. All right, so we have built our loading data, and I'm reasonably confident that we have loaded it correctly. You'll notice that when I load the data here, I actually don't use either of these two. I'm realizing that kind of in my head, I had thought a little bit too far, so these two are not necessarily useful. I'll comment them out for us, and we might revisit them later. Hopefully, we will revisit them later. All right, that's actually one of my favorite features of Visual Studio Code is being able to just collapse the code of a function. And there are a lot of IDEs that do that. I think CS50 IDE does not, though, and it's really annoying. Cool. So we're going to, I was going to say we're going to fit the model, but we don't have a model. My next thing would be, okay, let's train our model on things. But we don't actually have a model to train, so let's build a model. And this is, I think, one of the coolest parts of what we get to do. So, building a model. I'm going to create a kind of global variable. It is global, actually. I don't know why I put quotes around that. And I'm going to call that sequential. Or, sorry, I'm going to call it M, and it is a sequential model. And that's going to be global because all of our functions are going to access it. You might be thinking to yourself, oh, this might fit really well in a class. And you'd be absolutely right. This is actually really well implemented as a class that has certain methods. But we're building it as a script, and here we are. So we're going to use BuildModel to actually construct our model and see what layers we can add to it and things like that. So the first thing that I might want to do is m.add, and that's going to be the way that we add layers to our model. They're going to be sequential, so that if we add a layer, that's the last layer, right? Like the last added layer is the last layer that we are going to go through. All of our data will go through that layer at the end. So the first layer that we're going through is the first one that we add, and we're going to have that be, dense. And dense is kind of just your standard, good old-fashioned neural network layer. It basically has a bunch of nodes in it, and those nodes are going to look like that's the number of nodes, roughly, that it has inside of it. And that's pretty much all you necessarily need to know about what it does as far as technical specs go. But we're going to add a bunch of parameters to it because this is our first model. Or sorry, our first layer. And in our first layer, we need to tell it the input size that it should expect. So this sort of thing is always very annoying. Dense requires a bunch of parameters. I know input size is one of them. So we're going to give it the input size. And the input size is going to be something like, sorry, we specified 500, 500, 3? Question mark? That 3 goes either there or on the other side. I can't always remember. It's close to that. We're going to give it an activation. And with binary classifiers, they use a sigmoid activation. And you might be wondering, what is an activation? Great question.
What's a sigmoid?
What's a sigmoid? Also a great question. And so basically what that means is activations are kind of the initializations of our layers. So our layers, in reality, they're just a bunch of numbers. It's really just like a weighting of numbers. And then those numbers are going to be kind of modified as we go, and then that weighting will change to hopefully give us some answer. And so those numbers, they need an initial value. You might default to 0, but that actually, based on the math behind it, doesn't necessarily give us a whole lot to work with. Sometimes that can actually cause you to get stuck in one particular version of your model. And so this activation is an initialization to it. It's an initial set of values. And so Sigmoid, you can think of it as if you were to plot it out, it has kind of that classic curve structure to it. And that's going to be what you actually would imagine if you were to plot out all of the activation or all of the individual nodes' individual values kind of from an arbitrary left to right. It's a little bit hard to describe without the theory underneath, but that's roughly what's going on. We're setting a bunch of numbers equal to a kind of pattern, roughly speaking. And all that means for us is that a sigmoid response is really good for binary classifiers because binary classifiers have one of two answers. It's either up or down, it's either 1 or 0. And so a sigmoid response, what that might look like if you know anything about signals processing or kind of filtering of images or data or even music, then a sigmoid response makes it really, really hard to land in the middle. It's very difficult for me to be halfway between. It's really easy for me to be 1 or 0. And so that is basically what we're looking for. That's the behavior we're looking for in this sort of model. So we're going to stick with sigmoid activations for most things. We will kind of see a bug that I introduced to myself last night, where if you choose the wrong activation, we can actually get totally random behavior from our model, and that's kind of cool. But we're going to stick with sigmoids for now.
Metal Eagle has a question there for you. If you want to pick that one off.
Oh, awesome. So Metal Eagle asked, what is the problem of git add dot? Should you have a habit to run git status beforehand to make sure that running git add will not break anything you do not want to commit? I have broken all sorts of things that I did not want to commit. I've committed API keys. I've committed my own personal keys to things depending on what you're building. So yes, you should definitely make sure running git status is another really good habit that I do not have to kind of make sure what you're actually committing. Git add dot is problematic, I think, because let's say that you have something in your directory that is not part of your project. It just happened to be in there because you were maybe reusing some old code or you wanted to look at something for an example, and I've certainly done that. You probably don't want to add that to your Git project. You don't want to put it in the Git repository history. Because of the way Git works, it's a feature, not a bug. You have access to all the previous things. So, excuse me. If you were to add some sort of API key, for example, then using git add dot means that that is now permanently part of your Git history. GitHub has a really cool tool. It's Git Guardians, actually. They kind of monitor perpetually for API keys, and they'll email you, and they'll kind of block your repository for a little bit until you get that sorted out, and that's really cool.
That's a cool feature,
They've emailed me a couple times. I occasionally am just really trying to go, and I'm a little careless.
Do as Nick says, not as he does.
Right, exactly. I picked up some bad habits along the way.
Twitch Hello World says, I couldn't see the live stream video in the app, so I missed the start. Are you in CS50 Sandbox or somewhere in TensorFlow?
Yes. So we're not. We're not in the CS50 Sandbox. We are using TensorFlow. We are in Visual Studio Code on my local environment. So I'm just using this on my laptop, and I will be kind of pushing code in chunks as we go to GitHub. So basically, whenever I get a chunk of code working, then we'll actually push that to you guys, and you're welcome to copy it down and see how it works on your own machine. You will need TensorFlow. You will need Keras. You will also need Pillow. You will also need OpenCV. Actually, you know what? I can make that really easy because Python has the freeze feature. So I can freeze, which basically means take all of the current Python packages you have and output them. So if I just run pip freeze, then it'll output all the the packages that I've downloaded and I use. And there's a few more than you might think. I only downloaded Karis, but Karis, for example, downloads three packages. So this is actually a really good way to transfer what Python things you're using. And so in this command, I just kind of piped all of that output into a requirements.txt. It's a very common feature on pip or Python packages and modules and things. And if you wanted to build from that, you could do pip install -r of requirements.txt, and that'll pull all those requirements in the correct versions, or at least the version I'm using, to you. So I'll also push that to GitHub. So we'll git add, git commit.
Thanks also to M. Kloppenberg for pitching in the React course that Jordan Hayashi taught, which did cover JavaScript, and for mentioning that we are using VS Code.
Awesome, thank you. All right, so you should have a requirements.txt file in the repository now, and that should help if you're kind of trying to get everything set up. Cool. So we now want to continue adding layers to our model, and we can think we can keep things actually very simple. So we add this dense layer. I'm positive I'm missing a parameter. I think it goes in the beginning there, and we're going to figure that out when it doesn't compile. But this dense parameter is just your input. That's the first thing that's available to us whenever our data goes through our model. The next thing that we want to be able to add is our models are images. Images in general are displayed as arrays of some sort of data. And in our code, they are also arrays. They're numpy arrays, but they are still arrays. And we're going to need to kind of modify that a little bit. We need to tinker around with what exactly we're seeing. So actually, we're going to change this beginning layer to be a convolutional layer. That's what I was forgetting. OK, we're going to use a convolutional layer at the top. It still uses basically all the same parameters, except it has an additional parameter, which is its filter size. And we're going to use 3 by 3. That might be a named parameter. I'm not entirely sure. And so convolution is a operation that you can do on like signals data from anything, from like visual signals to auditory signals to electronic ones in general. And a convolution, mathematically speaking, is you take a signal and you take a response and you loop the response and pass it over the signal. And if that sounds complex and kind of difficult to understand, it is. I don't necessarily fully understand it either.
Is it kind of like feedback almost?
Yeah, exactly. It's kind of like your response to what's going on in the signal or the way that two signals might interact. I would think of it maybe like that.
That makes sense.
Yeah.
Almost like the messing with the image data that we had too. It kind of feels similar.
Yeah, exactly. It's just a way for us to kind of manipulate the image data. What convolution will do for us is I believe in this case, if I'm not losing my marbles, it is convolving the image with this 3 by 3 array. And what that's going to do for us is make our data a little bit more not centralized, because that's actually what our next layer is going to do, but it makes our data more readable and friendly to the machine. So it gives it kind of some features that make our machine a little bit happier.
Massaging the data?
Exactly. That's exactly what it does. All right.
Bad Knight says, why not pip3? Why are you using pip instead of pip3?
So actually, if you look at which pip, or pip -- version, this actually is pip3. I happen to use pip because it's alias to the same command. So pip3 would also work. There's not necessarily a difference between the two. However, there is a difference if you're on a Mac and you use the installed version of pip versus the system installed version of pip. And that is one of the most annoying bugs you will ever encounter. Almost guaranteed.
CLV Twitch says, will the videos be on YouTube so I can watch them later? Yes, they will be. If you just go to YouTube and type CS50 on Twitch, you should be able to see our playlist. And it's also CS50's YouTube channel where David posts his lectures and a bunch of other course videos.
Awesome.
Gaston says, hello, are there any interns open in Silicon Valley? I would Google and see. I'm sure there are internships available, but none that necessarily CS50 is directly affiliated with or knows of at this moment. But definitely do some Googling and see, and I'm sure there are links on those websites that you could reach out to get some more information on them.
And Bhavik Knight actually pointed out that convolution is output going into the input again. That is actually, yeah, exactly. That is what this convolution does. So it's not the general definition of convolution, which is what I was, I guess, stumbling through. But it is the convolution that happens here. It convolves the image with itself. Thank you. That was something that was very important that I could not, for the life of me, remember how to talk about. Cool. So now we're also going to...
You could say it's a little
it's a little convoluted. That's awesome. Yeah. Man, I love puns. Puns are the light of my life. All right, so we can also add this max pooling 2D layer, which sounds very... sorry, I was reading the comments, and it's kind of funny. Sometimes you guys have just these entertaining comments. OK, so we're adding a max pooling 2D layer. And that sounds kind of ridiculous, but it's not. Max pooling just means that we're looking at the maximum of the values in a given range or kind of frame. We're pooling all of those together, and that's going to be kind of representative of that actual area. So like if you could imagine it as like taking like a 5 by 5 array, and the maximum of that is now representative of all of that 5 by 5 array. So it could be thought of as like feature, man, the word is escaping me, combining features or feature combination. And it basically just means that some of the data in our image will get ignored, but we're assuming that the maximum part of our data is the important part. There's also like min pooling and there's average pooling. There's a bunch of other ways that you can pool data. There's all sorts of things you can do with it. And then 2D means two-dimensional. We are using two-dimensional data. So the parameters to max pooling 2D are something like filter size, and this is just that, like how much of what's the size of the pool we're using. Activation is definitely one of those parameters, I think. Okay, I say definitely and then I said I think. That's self-contradicting. I don't know if it takes anything else. We'll find out. This is generally something where I don't necessarily memorize it because I can just go look at documentation. And then we're still working with an image, which is not super clean. It's not super easy for our machine to then put out a 1 or a 0. So what we might do is something like this. Model.add of a flatten layer. And that pretty much does exactly as its name. It just flattens the image into kind of a one-dimensional stream. And so if you did CS50's kind of resize recover and you played around with images a lot, you could think of them as all having been flattened. So they're no longer represented in two-dimensional arrays. They're represented kind of like a stream of data, and there is some breakpoint that's logical. But to a computer, those breakpoints don't matter. They're kind of irrelevant. So we can actually then flatten our images, and now that we've kind of done this max pooling and convolution of the image, we can flatten everything and then just feed that into kind of standard, like dense neural network models. And that should be pretty reasonable for us. And we're actually going to do exactly that. We're going to add a dense layer to do some kind of minor computation. I like to use powers of 2. That is certainly not it's not a requirement, but I like to use them. And that's just the number of nodes within our layer, roughly speaking. It's not exactly correct, but it's close enough. And then we're going to add our final layer, and this one has kind of a specific set of parameters. It has to have the number of nodes within it be actually 1. And the reason for that is we're using a binary classifier, so we want it to output only using one node or one number. We don't want it to output a bunch of nodes because then each of those nodes might be weighted to something else. They might represent kind of non-existent or imaginary classes, so we don't want that. Cool. And then we're going to give that one a sigmoid activation as well. So now running through this in concept would work, but you'll notice that in IntelliSense it actually highlights all of these things, or all of the layers that we just added because they haven't been imported yet. So what we're going to do is import them. And I believe it's from keras.layers, hopefully. Import dense, can't remember the name, conv2d. I will say max pooling. Oh, I love IntelliSense. It pulls things that I don't even have up here yet. Flatten, and I think that's it. So those are all the layers that we tried to use. Oops, that's not what I wanted. And now that we have everything going, oh, I killed my virtual environment. That's a bummer. We should be able to get this model built. Now the problem is that we haven't necessarily linked them yet, but I also think I'm missing a parameter here. I think I might have not named it correctly, but that's okay. We'll be told that very shortly by our python run.py. Well, if we call BuildModel. So BuildModel is a little bit strange, and it deviates from the standard paradigm that I like to use in that it has a side effect and doesn't actually return anything to us. So BuildModel is kind of like print, where you just run it and things happen and you don't necessarily know what's going on underneath. I'm not a huge fan of that. I prefer a functional style model where you get a return given some input, but that's okay. We're using this more as like a weird hybrid between scripting and modular building. So it's like kind of halfway. So we can go ahead and run this, and it should run without problems, minus the fact that I think I have, oh, okay, well I also can't spell. No surprise there. Now that I spelled that correctly, this should run mostly correct. Yes, input size, not a keyword. We're going to go and look at some documentation. You would think I would know that part, though. I believe it is, well, okay, I'm obviously wrong. It's not input size, but it's like, I know there is something there. Let's look at, oh, right, sorry. Convolutional layers, that's what I was trying to look at. Conv1d, conv2d, there's all these things. So we know that we need a filter. This is the number of filters that that convolution is going to have. The kernel size. So those are two positional arguments. And I actually might have, yeah, passed those correctly. Cool. I just forgot how to name it input, or tell it what kind of input it takes. Input shape. Input shape. There we go. So that's correct. So what this actually does, and you might be wondering, oh, it's probably filter shape as well. Or size filter. There's all sorts of like variations on these. So what this does is we didn't actually have to pass an input shape to all of the other filters because they can intuit them from the previous one, or from the previous layer that was being used. And so that is kind of a cool feature, and it's certainly one of the benefits of Karis, is you don't necessarily need to keep track of all of the individual things that are going on in between. You can kind of just stick to adding layers in a sequential order. All right, I apparently don't know the name of that. One of these days. Let's see, where do they put their, they might have called that merge, or merge is their own layer. I haven't seen that one before. Add, subtract, concatenate. Oh, well, we can also use max pooling. And this will bring up, wow, or it won't. Oh, wait, there we go. Cool. Max pooling 2D. It seems to take a second. Okay, here. We'll look at that. Max pooling 2D takes not, oh, it's pool size. Well, that makes sense. That's kind of intuitive. All right, cool. So we have corrected our syntax, and I believe that fixes all the rest of our syntax errors. And that should be able to, or not. Did I misspell that? Yeah. It might not take an activation. I mean, you're really seeing this live. You quite
That's
actually.
Part of this, part of the fun.
It is part of the actual fun to this. There we go. It's like literally just tinkering around with what exactly I remember and what I don't. Cool. So we have now added correctly a convolutional two-dimensional layer, a max pooling two-dimensional layer, a flattening layer, and then two dense layers, the last of which is our output one. And that's going to return to us a number that is either 0 or 1. Well, kind of. It'll return to us a number that ranges from 0 to 1. Won't necessarily be 0.
We have a couple of comments here if you want to read some of these.
Cool. Yeah.
Okay, so Augustin says, here in Tunisia we study many, many technologies and access to Silicon Valley is restricted. I want to guarantee choice because that would be very useful.
Okay.
I'm definitely not an expert on the programs that Harvard offers. I would probably just say Google for international transfer programs. I know we definitely have Harvard students from Tunisia who have come here. But I can't speak on that. I'm not an authority on that, and I don't know anything about anything related to Silicon Valley directly because just familiar with what goes on here in Cambridge at Harvard University, I'm afraid. But definitely do dig around a little bit, see what the research or the transfer programs look like. Look up Silicon Valley companies, see if they have any programs related to international work. I know that some companies probably do have something related to that, although I'm not going to say, I can't speak on behalf of international work-related laws, so I'm not sure. But again, I would defer to Google on that probably. So afraid I can't give any better information than that, but I'm not an expert on that. 42.4 says, thanks for doing this.
Oh,
so
thank you. Yeah, thank you for being here and watching. We appreciate it. What structure is a sequential? So sequential is actually its own class. It's given to us by Karis's models submodule. And it does kind of work like a set, and very nice intuition on using, like it has the .add method, but that actually is unrelated to the fact of like how a set works. I believe they do use an underlying structure. It's not a set, but I believe they use an underlying list to keep track of which layers you added when. But that add method has a bunch of other stuff that goes on underneath to like verify your layer and translate it accordingly TensorFlow-wise. So very nice intuition, but it actually is kind of Karis specific. And thank you, Nuwanda, for pointing out I did miss an S in Karis. Same thing at Bella Keras. I did miss the S.
Part of the fun of live coding.
One of the great parts.
I feel it 100%.
Yeah. Awesome. Are there any other comments that were going on?
I think we grabbed all the questions there.
Awesome. All right, so I just pushed the build model part, so you should have access to building the actual model. We are going to revisit the way this model works, because it probably won't work super well. It's not very complex, but it does work in concept. So now we get to kind of the exciting part of fitting our model to our data. We have a model, it's been built. We now just have to actually fit it, or train. So I'm actually going to use the word train, because that's what I called our data. It's like subdirectories. But we're also going to use kind of just this, it's actually basically a one-liner. It doesn't really return anything to us. It just takes the model and says, you know what, now here's a bunch of data. Tell us what happens when we shove it through you. And we give you the answers along the way. So again, syntactically, this is going to be kind of fun. Go figure. Even after years of doing CS and years of working with the same modules too, still looking up syntax occasionally. It happens. It's okay. So we're going to, in our train model, we're going to want to have both the training data and the testing data. We're going to use the testing data at each step to kind of validate what's going on. The training data is going to do exactly that. It's going to help us train our model. So we're going to use m.fit_generator. And that's the actual parameter. It's very similar to m.fit, except I'm not supplying manual data. I'm supplying a kind of generator. It's very similar in concept to Python generators that just generates data as we go. It'll never run out, which is really cool. And I remember approximately 0 of the syntax for this, or at least the names of them. They do change from time to time. This actually used to be NB epochs. And epochs, or epochs, is just the number of times that we run through the training set of steps. So it's how many times do we actually just try to train the model. And so what this means is that if we run like 10 epochs, whatever it is, you'll know what I mean. If it sounds funny, that's okay. You can make fun of me. So as we go through for 10, on the first time, the model's just totally fresh, been not trained on anything. But on the second, third, and fourth times, and kind of every time after, it's going to have picked up knowledge from all the previous times. So it's basically it practicing. I would think of it as just kind of practice rounds for the model. So we're going to start with just 10. And then we're going to say batch size.
Does it save these sort of iterations of data collection, data gathering?
No, it does not. So it doesn't really save them anywhere on files. So when you get to the end, it actually just tosses the model, unless you save it yourself. Okay. So we're actually not going to save them until kind of later when we actually have some models that we are like satisfied with. But no, it doesn't actually save them on each epoch. You can, Karis has these like beautifully built structures for things. They have these callbacks, which if you're familiar with JavaScript callbacks, it comes from the same terminology. But what that lets you do is at the end of every epoch, you could actually save that version of the model. And if you're running like 1,000 epochs and you have just these enormous batch sizes and you really want to make sure that at every stage you could like tell us like something about the model at that stage, then you would want to do that. And I don't think I'll probably cover that here. It is a little bit more advanced and a little bit more, I don't necessarily know it off the top of my head, but super cool, and Karis has all sorts of like powerful tools. And as I said earlier at the very beginning, they actually just updated some of their documentation, and they have all sorts of cool things that I haven't even seen yet. So I'm really excited about that. Whipstreak also just asked, are we only using Python? Yes, I happen to particularly love Python, although you could also code this in C++. I believe they have libraries for it. I don't know if Java does. I don't believe it does, but C++ would also probably work. It would be a little bit faster, probably. But we're going to stick to the Python implementation of Keras and TensorFlow.
It's clear that this is quite a rabbit hole to go into.
Yeah, it really just fans out. There's all sorts of things you could do. I mean, there's just so many ways in which you can change what's going on here. And we're going to switch back to this to get kind of on our fit parameters. What do we actually need as far as that goes?
Blue Booger asks, could you use R? And his name is actually blue in our chat too, which is all the more appropriate.
Yes, I believe R has a library. Actually, Bob Ignite just answered that. I believe there is a library for it. I am not super familiar with it off the top of my head.
TensorFlow. Does
yeah,
TensorFlow
I believe
have,
TensorFlow for
interesting.
R. Oh, yeah, look at that.
Oh, that's cool. Yeah, TensorFlow does have
Nice.
an R binding, which is nice.
Yeah,
Cool.
look at that. Yeah, so TensorFlow is really beautifully well done. It's a Google project, and I'm a little bit biased, but I think they do a really good job. So, you know, it's very, very cool what they've been able to put together for us. Let's see if I can find where fit generator is. It might be under the sequential model. Oh, actually, they throw it in image preprocessing. I do remember that. So let's go see what they actually do. We're going to just copy all these parameters because we're original. And I'm going to paste them all here. They did
Copying and pasting is a real developer technique, though.
It really is. It is a very, very valid developer technique.
Stack Overflow, hashtag Stack Overflow.
Exactly. And so we're going to just change these to our variable names. Steps per epoch, 2,000 is quite a few. Generally speaking, you would want to actually run many, many steps on these, but our data is pretty small, and we can actually get really good results with pretty low numbers of steps.
And oftentimes, big companies are using like massive server farms for this, aren't they?
Yeah, they use enormous
not just like a
computational power.
A MacBook Pro.
Yeah. Yeah, we're running this on my local laptop. This is my just personal student laptop. But yeah, a lot of big companies are running these on just enormous clusters of paralleled networks and things. They have all sorts of like network capable computational sharing. They have some just supercomputers running it. There's a lot of money going into this. And there's a lot of just people really trying to get these things to work for all sorts of crazy things. I know there's a project at Lyft that does something really cool with simulating like a bunch of just real life data in real time, and they just test random machine learning models on it, or not random, but like their own personal projects on it, and that's super cool. I know Google has, I'm sure, just millions of projects that we don't know about. There's all sorts of really cool things going on. All right, so we have done kind of this train model, which does call the actual fit generator method. And what that means is I'm going to then call that in the actual scripted part of this, and call train data and test data. And in concept, this should actually run. This should get us pretty close. Oh, okay, I tried to git push. I made the mistake of going up and pressing enter without even looking. That was great.
It's a hard habit to break.
It really is. You must compile your model before using it. That's entirely reasonable, and I completely forgot about it. Okay, technically, build model is incomplete. I forgot to, compile the model. So compiling it means you're telling TensorFlow, oh man, I cannot type, that you are done adding layers to the model. You want it to be all put together, assembled into like tensors in this beautiful pipeline. And so that's what we basically end up having going on there. And that's what we're going to run here. It also takes a couple of arguments. For example, it takes an optimizer, which is mathematically a tool that makes things a little bit better as far as how each layer or how everything kind of takes feedback. So when it's told what the actual answers were, it optimizes for making sure that we don't interpret that incorrectly. I would think of it like that. That's not exactly what it does, but it is kind of the right idea. I'm going to use SGD, which is the, man, I am forgetting names left and right. That is the name for something. Actually, we can switch this to Atom, which is, again, I don't remember the acronym, but it is a version of an optimizer. They each just do slightly, well, some actually majorly different things. And you'll notice some different results depending on what you're doing and which optimizer you use. We're going to also add metrics. This takes a list. We're going to do binary cross entropy, which sounds really fancy and like great party term if you're at a party of nerds. And like it's a really fun term to throw out there. There's also categorical cross entropy. I think that one's even cooler. It's even longer. And so what that basically just means is every time we do I got distracted by a comment. That's really funny.
We go back up to whip streaks there. He says,
right. Sorry. Okay. So I was away, only came back now. Do a summary. Yes. I don't know exactly where you left, but we are currently trying to get our model learning on data. And so what that means for us is that we want to be able to actually run this train of the model or fit the model to the data. And what we kind of, what I forgot about in the interim was that I actually have to compile the model, which means giving it an optimizer and like what metrics to use for how well it's doing. And that's, I think, what will catch you up.
The video will be on Twitch as a VOD to look at later, and also on YouTube tonight. You'll be able to look back on it if you missed anything.
Awesome. And then we're checking in on who Bhavik Knight is. That's kind of cool.
Part of the Handmade Hero stream. I've checked that out a couple times actually. That's sweet. It's nice. It's a guy who makes a game, complete game from scratch, 100% in C, which is pretty cool. That's crazy. And he's got like 1,000 videos up right now. It's pretty ridiculous. Dang. Oh, but I guess Bhavik Knight's not the same person that's on the Handmade Hero stream.
That's crazy.
Just happens to be shared by another person. Happens to have that handle.
I didn't even know that was possible.
And then Gaston says, I recommend to have a live session of parallel programming. It's just a hard thing to understand.
Actually, we could do that.
We could take a look into that at some point, yeah.
And actually, it'll come up a little bit here, too.
Yeah, okay.
We do use it a little bit. But yeah, that'd actually be a really fun one. We could even like parallel code it and then see if it works. Kind of motivate it that way. And actually, that's, I can't read that name, but...
It's Blue Booger.
Oh, Blue Booger. Ah, my favorite. All right, so Blue Booger then pointed out that we are parallel programming right now.
Except I'm not actually programming. I'm a bystander in this right now.
You're a waiting process.
I am.
You are the parallel equivalent of a waiting process. That's awesome.
An infinitely waiting process.
Yeah. The wild true process.
A daemon thread.
Yeah. Oh man. Yeah, you gotta, I don't know. I think if you don't appreciate puns and jokes in life, then it's just kind of sad. It's just really depressing. All right, so we have an optimizer, we have metrics. There is a third thing that I am missing, and I can't remember what that is. So we're gonna go find it in the documentation.
This is part of the live coding thrill, man.
It really is. Like we're looking left and right at documentation.
It's a good documentation consulting tutorial.
It really is. We're like, Karis, your documentation, it is a lot better now. I really appreciate what you guys did on that. Like, great job. It's making my life a lot easier. It used to be, I think, a little bit of a mess, but there have been a lot of like cleanups on it. Things have been updated. It's great. I'm a huge fan of up-to-date documentation. And if you can read documentation and be like, wow, like things work. Oh, right, loss. There we go.
42.4 says, what you said, Nick, is true about puns and such.
I really appreciate that, yes. That's kind of one of my life philosophies, especially when you're like sitting up late at night and just trying not to stay up until the sun comes back up. Puns keep you going. All right, so I actually misspoke a little bit earlier. I said that binary cross entropy was a way of metricizing what's going on. Apparently, I'm kind of losing my marbles. That is actually a categorization of loss. It is, in a way of looking at how things are going wrong, but loss is basically, there's a whole lot of theory behind that, but you could think of it as like the way that, like kind of the loss in accuracy that the model had. So on that run, how poorly was it doing? The higher it is, the worse it goes. The metrics are what we're actually using to display in like a human readable format. Like loss doesn't necessarily mean anything to me. It could be like 42. That might be meaningful, maybe. They're more useful as like a relative metric, but metrics on their own, like accuracy, that's super meaningful to me. It means what it says. It's an accuracy, usually given as like a percentage. I think mine, like in this case, will be displayed not as a percentage, but as a proportion of 1. So you'll get like 0.55. Not great. 0.5 means we're literally guessing. 0.45 means we're doing worse than guessing, so we're anti-guessing. We got it right, but then flipped our logic. And then 1 is ideal in concept. Cool.
Asley Nuanda3333, who's Asley Tumerkin, says agreed. Hope you do more sessions, Nick.
Awesome, thank you. I really appreciate it.
Tune in next Friday for
we'll
a
be here next Friday.
Linux command tutorial.
I very much enjoy that. I appreciate it a lot. And now we're going to see if we get this to run. That's one of my favorite. I mean, I say that to myself when I'm coding things. Hey, look, it worked. I'm not actually surprised it worked. I'm like a little bit surprised it worked. Cool. So I'll tell you what's going on here while it runs. It's running exquisitely slowly, which is awesome. It wasn't running so slowly last night, but you know, we're live streaming.
Exquisitely slowly.
So slowly. Every time you like live stream, something that ran in like maybe 1 second will take 4 hours. Like if you like had a download that took a second, it's 4 hours now. Like there's just no.
It feels like 4 hours.
Yes, especially when you're sitting there just waiting. But there's a lot for me to explain here, so we're going to kind of go through what's going on. So you see this bar kind of increasing on the left. That's telling you your progress through the number of. I'll see if I can find it in the code because that would contextualize what's going on. The number of steps, right? So each one of the. Oh man, that was awful. Each one of these little bars that goes through on the bottom here is going to be 1 step. Each line is one epoch or epic. And that's going to be just, we're going to run through 10 of them as per our parameters. But then our steps per epoch is how many steps do we actually go through trying to train our data. And that's going to be 20 in this case, and it's going to count through each one that we walk through. And then it tells us an ETA. Those are generally fairly accurate. I found them to be pretty reliable. This is the loss that we mentioned earlier. Not particularly meaningful. You generally want it to go down. That's pretty much all we really know.
Also, your computer is whirring right now.
It's really funny. If you like run these in class and you're like supposed to be paying attention to lecture, then people will kind of start to look at you as your computer just starts to get closer and closer to just exploding. And I think it freaks people out. They're like, oh God, why is your computer panicking? And then we get to this accuracy metric, which is what we mentioned before. And you'll notice there's actually 2 of them. There's accuracy here, and then there's val accuracy. What that stands for is this is the accuracy on the training data. So that generally will go up just regardless as it starts to memorize things. But the validation accuracy, should give us some reasonable metric for how well we're actually doing. And what we can do is, if this validation accuracy is substantially higher than the training accuracy, then you're doing a pretty good job. You're literally predicting data that you've never seen before better than the data you have seen before. And that's not something that happens very often, if ever. It's something that would be pretty rare. If the validation accuracy was at 100 and our training accuracy was at like half, then, oh, sorry. I forgot that we were on the screen. Right. Thank you, Colton. I appreciate it. You'll see it. I can actually probably move it up a little bit, and that might help.
Dug down just a touch.
There we go. Oh, well, that's close enough. So yeah, that'll show up again when this epoch finishes. And so validation accuracy versus accuracy are really good to kind of compare. If validation accuracy is substantially lower than accuracy, and unfortunately that happens kind of often, that means you've probably overfitted your data because when you're given new data, you're kind of just like, oops, I don't know what's happening. But given data that you've seen before, you're pretty good at it. However, what you might notice, and it takes a little bit at the end here, you'll notice it kind of freezes on that last step in the epoch. That's because it's running all the validation steps, and they take a little bit too. You'll notice that our accuracy is at 0.5, and it's staying uniformly there, which is not great. That basically means we're randomly guessing, and we're randomly guessing really well. We're just really random. And what I mean by that is, like, even if I were to flip a coin, I would probably hover around 50. I'd have a mean of 50 and an expectation of 50%, like 50% heads or 50% tails. But I wouldn't get exactly 50%, at least not usually. So the fact that we are sticking at 50% is kind of a result of the fact that our data is pretty well balanced, but also we're just really random. We're true randomness here. We're literally guessing. And so that's not ideal, probably not what we were looking for. So that means that we now have to debug the actual model. And I guess we kind of deliberately left this here, where I made some of the mistakes that I made last night, but I made them again for everyone else to see. And that's because they're really common mistakes that show up all the time in machine learning. So it's really easy usually. If you're given some sort of Python code or C code, how do I debug it? How do I go about fixing that code? And the problem with kind of machine learning style things is we don't necessarily know where to go debugging wise. There's no real like article on how to debug a machine learning model. There's a bunch of really technical ones, but there's none that are really as approachable as this code seems to imply it should be. So we have a bunch of things to look at. How do we build our model? How are we getting our data? How are we kind of manipulating our data? And what kind of optimizer are we using? And what kind of activations do we have within building our model? So I'm going to let this keep running, and we'll stay at 50, but that's okay. It's kind of cool to just watch it go. We can also make this a lot faster. So there's some other kind of things going on here that can make our lives a little bit better. Let's go about making it faster first. So this is use multiprocessing, which is something that I think is correct. And we're going to say false, but I'm going to say the number of workers, or the number of independent threads you can spin up, is 4. And what this means is a lot of machine learning stuff can actually be done in parallel. I don't have to do it all in one thread on one processor. I can spread it across as many processors as I want, limited by the number I have. And so what I'm going to do is I'm going to say, you know what, you can actually use 4 workers or 4 threads, and I turned off multiprocessing. If you use both at the same time, Karis will give you some warning and be like, yeah, don't do that. And the reasoning for that being basically you're attempting to do kind of 2 versions of the same thing. I say that and I'm sure someone somewhere just cringed. They're not actually the same thing, but it would accomplish a lot of the same goals. So we're going to just use one instead of the other. And I'm going to kind of rerun this now. It should run a little bit faster, which would be ideal for us.
Machine learning takes a long time.
Machine learning can be very problematic as far as timing goes. And
learning in real life takes a long time, so I mean, it makes sense.
Yeah, exactly. And we have one of the most powerful computers in the known universe, actually, which is crazy. So it is going very marginally faster, but not necessarily a whole lot. All right, so now we need to kind of look at, well, what are we doing that might be breaking our machine learning model? Why is it not learning the way we want it to? So some things, and this is where we get into kind of like a guess and check sort of thing, and the like programmatic part is where you're looking, where you're guessing and checking. So the first place I might look is in the way I built my model. Is there something inherently that jumps out that tells me, yeah, this is incorrect, like something here just doesn't work? So I noticed that my activation here is sigmoid, which is right. That's what I want for a binary classifier because of the same reasons that we mentioned earlier. My activation in all intermediate steps is also sigmoid, but I could change that. I could make it like ReLU. I don't actually know what that stands for. I did at one point. I don't anymore. Or like something like TANH, and both would be reasonable. There's no real reason to pick, or there is a real reason to pick one versus the other, but we don't necessarily need to care. But I'm going to leave that actually as sigmoid. I'm going to look at the original activation, which is also sigmoid. And that might be kind of problematic. It might not necessarily be the source of our bug exactly, but it might also be something to reconsider. In that we said that a sigmoid activation kind of creates it so that you're in a binary state. It's either down or up. And we don't necessarily, thank you, Magus503 just pointed out that ReLU is rectified linear unit. Thank you.
And Gaston said, can I work with you guys? I need a Skype interview with a company in America. So CS50, to the best of my knowledge, is not currently hiring. When we do hire, we accept all applications. Normally they're posted on our website, cs50.harvard.edu. But like I said, I don't believe we have any job openings currently available. In terms of getting a Skype interview with a company in America, that's also something that we probably won't be able to assist with, but definitely reach out to companies you're interested in working with. Most companies have links on their website for applications. Definitely build a portfolio of projects on GitHub or the like so that you have more code to share with people and keep the search going, but I'm sorry that we're unable to provide any more than that currently.
But best of luck.
Yeah, definitely best of luck in finding something. There's tons of openings, I'm sure.
I mean, there's just all sorts of companies want people who know anything about coding or are looking for just people to, I guess, put in effort and work. I think, we'll go on a short aside, like for 4 seconds, that I think that don't ever lose motivation on these sorts of things. As someone, I sent out, I think, like 104 job applications last year. I got rejected from most of them. I was, you're really trying to get a job, and for me, it's like, well, I want to be doing something with my life over the summer. I want to actually be contributing. So just don't give up. just keep going, keep pushing through. Rejection, people very clichédly will say like rejection makes you grow or rejection teaches you stuff, but I learned a lot from my rejections, and I think that they actually do help you a lot. So
yeah, there's a phrase that I like that's, who came up with it? Be so good they can't ignore you? Steve Martin,
right. Yeah, yeah.
I believe.
That's
a good phrase. You know, keep working hard, and if you're really, really, really good at what you do,
yeah.
you just won't help but be able to get something somewhere that you want, right?
I think Lang Lang, the pianist, has a phrase or a story in his book where there's someone who like hates him and is a judge for his piano competition, and even they can't deny how good he is. And I think that that's really just super cool. I think that's super inspiring.
Yeah.
All right, so we did change some stuff about what was going on in our model. I rectified, so to speak, the activation of our input layer. I changed it from sigmoid to rectified linear unit, or ReLU. And that actually caused our model to start doing some interesting things. It's still very slow, and we added some extra workers, but it's not necessarily going that much faster. But if we look down at our metrics here, and I believe Colton might be in one of the metrics, but we can just kind of raise it up.
Oh, I'm sorry.
Oh, no, you're all good. We can just do this.
I
think
cut
it's
off
above
there.
you
Gotta
now.
go this way.
There we go. I think you're good. I think you're good. Cool. All right, so what we can look at here is in this first line, in that first epoch. What we see is our losses, whatever, it's some set of numbers, but our accuracies, our accuracy and validation accuracy, are not 50, or 0.5. Sorry, I'll probably refer to them as percentages, but they are technically fractions between 0 and 1. So they're actually 70 on our training data and 100% on our testing data, on our validation data. And I mean, if you recall, or maybe like currently watching in the future, weird. Then you might recall that I said it's pretty rare that you have your validation accuracy go higher than your actual accuracy, or your accuracy in your training data, because you generally learn your training data a lot better than your validation data. But in this case, we are using something that's fairly simple, and we are technically solving a problem that isn't too terrible. So we actually see that our validation accuracy in now 2 epochs out of 3 so far has been higher than our training accuracy. And we do happen to have just more variance within our training data set. It's bigger, it's double the size. So it kind of makes sense that we might see something like this for a pretty simple problem. So we're going to kind of let that keep running. It's still very slow. And something that, I mean, the reason I keep pointing that out is to motivate the rest of, or the next part that I'm going to talk about. But it would be really cool if I could speed that up and not lose accuracy, right? Because I mean, that's the ideal. If I can make a machine learning model run really quickly, really cheaply, and not lose accuracy.
Millionaire, future millionaire.
That'd be awesome. I mean, you could make a startup right there on that. And I mean, that's a gross oversimplification of the problem, and certainly not something that we can do. But there is something we can do to fix what's going on here. Because I've mentioned earlier that these images, the size doesn't really matter that much, as long as we keep most of the important data, or most of the features. And we're using some pretty large images. They're size 500 by 500. And so if we're running through, 20, 40 images, and we have 500 by 500 for each, well, 500 squared, we're on the order of 10,000, or I guess 25,000 actual pixels or data points, times 40, so we're at the very least, what is that, 2 million? Or 200,000? I'm not very good at math. And that's okay. I think we're on the order of a couple 100,000 things and calculations that I have to go through all the time. And that's terrible. It's definitely not what we're looking for, and I guess not what we really need. So I would go through and change all of these 500s to then maybe something like 150, a very common version of that. The problem is I wrote it in a bunch of places, and it's going to just change in one way. I'm going to use pretty much square images forever. So this is a pretty good place to switch to some variable. So imdim, or image dimensionality, actually that's not a great variable name, it means something else. We'll say like image, we'll call this one width. It actually doesn't really doesn't matter which one we define as width and which one we define as height, as long as we're self-consistent. So I'm going to say image height and image width are in that order. And I'm going to replace all of our 500s with those, which should, if we don't screw up missing one of them, should help us out a little bit. And then, kind of similar to how we defined model up here, we're going to also define each of those. And we're going to bring that down to about 150 by 150. Let's make sure that I didn't leave any spare 500s. Cool. And now we know that we can control the image height and width by just changing kind of like a configuration variable. And in my previous project, or in the talk that I gave last year, the code that I used for that actually has just a configuration module, and you can just change config variables and it will change everything about how it works. And so I think that generally kind of moving those out of the actual code so that you can think of the code in terms of like kind of abstractly what it's doing can clean up a lot of your actual debugging and processing. So we're going to stop this, the currently running training session. And you'll say, it says user aborted, and that's great. We're going to run it again, but with our smaller sizes. And we're going to see if that changes kind of the speed at which we go. And I mean, I say that like I didn't know.
Visibly, it looks like it's definitely moving a lot faster.
Yeah, it's so much faster. And you'll notice our accuracy has not gone down. We're still interpreting these images pretty accurately. And you could think of this in kind of a human context is, if I handed you a really small image versus an enormous poster, you could tell me pretty quickly whether either one is dark or light. Right? I mean, you could look at the small image and be like, yep, that's dark. And you look at the big poster board and yep, that's light. And that's pretty immediately doable for us. So this is basically what we're seeing. We're seeing the machine equivalent of that. And right now, you could argue that we've overfit our data. That's probably true. But our validation accuracy is still also true. The problem is that that might lead you to think, oh, well, then we can now use this model and predict on kind of our prediction data, which is definitely our next step. But that's not entirely the case. You'll notice that loss parameter actually has continued to go down from row to row. And that tells us something about what we're doing to our data. It's one of the only times that I'm going to point at loss as something that we really want to consider. As that continues going down, it means we're getting closer and closer to just getting it right. But that's problematic on our training data because it means that we're overfitting. We're going to just hyper fit ourselves to this data set, and we're going to kind of put on our blinders and say, this is all I know and this is all I can ever deal with. And that's really problematic for like images, where even like 1 pixel difference means you have a different image technically. So we want to kind of prevent that. And luckily, right before we go into prediction, we actually have a layer that does that. So we're going to add that layer in between, sandwiched between 2 denses. And that layer is called dropout. And I know we are running a little bit low on time, but that's okay. I think we're actually going to run perfectly into.
We can go a few over if you need to take a few minutes.
All right.
Fairly flexible format on Twitch.
Right, that is a good point. It's actually one of the beautiful aspects of this. All right, so what we've done here is we've added dropout, which means every once in a while we're going to just randomly drop out data. We're going to just ignore it for that training session. And that's really cool. It means that we can actually kind of counterbalance the overfitting that we might do. I said 0.2, but I'm going to make it really aggressive. The term aggressive dropout is something that I think is really funny. It makes me think of like a college kid who just drops out of college and is like extremely aggressive about it. But yeah, we have this aggressive dropout, which means that we're dropping out a pretty high number of things, or data points at each point. And that's going to help us kind of prevent ourselves from overfitting. I'm also going to, now that we have this whole thing working on like up to training, I'm going to add that to GitHub. Added model training. And then we can git push. And so now what we have left to do is, can we actually try and predict on the data that we have in our prediction directory? So that's going to be our last step. And we're going to say that our predict on, we'll say image as well, because that's where our prediction data lives. So then in here, I'm going to say define predict. And it's going to take an image dir. And all we have to do is let's recall what the actual structure of predict is. So under image, under predict, it's just images. And what I might say is, OK, then let's actually just take those images and we're going to save their paths. I need to be able to save their actual paths. And that's actually what I had intended to do over here. I just kind of conflated the two in my head. And we now have this lovely line of code. There is no actual need to do any of this OS path joining. If you'll recall, we're just using listdir to tell us what images are in that. And then we're going to imagedir predict of what's going on in there. And this should give us access to all of the images that we actually want to use. Let me actually think through that before I tell you that that's the case. OS listdir, I actually do need the os.path.join. Not gen, join. It's one of the features I don't like of VSC. And predict. So now we have access to all of the images that we want to have prediction on. And I'm just going to call these im paths. or image paths. And the reason that I'm going to keep track of those is so that I can tell which image I'm actually making a prediction on later. And so I have to now load in these images. And this is where we actually use CV2. So let's say images is equal to, and I'm going to use, again, list comprehensions, cv2.imread of image for image in image paths. And this will allow us to actually read in each of the images. And then I'm going to, again, do images is cv2.reshape, I believe, of the image. And we're going to reshape it to our height. Oops, I called that imHeight. imHeight, imWidth, gotta love the autocomplete, by 3. And this is, again, for image in images. Cool. And what this basically does, and I'm kind of abbreviating the steps and cutting down a little bit on my narration, but cv2.imread means read the image into kind of what we're dealing with. It reads it in as like a numpy array. And then this cv2.reshape of the image actually puts it into kind of the right shape for us, I believe. I think that's a necessary step. I might be conflating it with the numpy version. And then there's also, yeah, I have a feeling I kind of mixed these two together. We're going to actually comment that one out for now. I think I'm talking about the numpy one. We have numpy.reshape, and that sounds much more correct. So I'm actually going to just copy the line I had above. And this basically just takes the images, like dimensionality, and reformats them a little bit so that we can actually feed them into our machine learning model. Our preprocessing step before, kind of up at the top when we load in the data, actually did that for us. We just didn't really realize it. Cool. So this should be all of our actual images. And then we're going to say predictions. Actually, we can just return from there. We can return, again, a list comprehension of m.predict. Predict classes. I don't know if it's plural. We'll find out. Gotta love the just random guessing sometimes. On image for image in images. And this will tell us, what does it think each thing is. However, that's going to return to us something that's a little weird. We can actually print it out. Print it out? Who knows? We can look at what those predictions might look like. And since we're debugging this and not actually the number of epochs, or sorry, not the actual model, we just want to see what it would look like later, we can actually reduce this to like 2 steps per epoch and 1 epoch. And that's going to be really fast. It's going to just kind of skim through. Oops, I just did git push again. There we go. Cool, I have invalid syntax, and that makes sense. I forgot the word in. Line 81. That's one of those things where if you're watching someone code, you see that immediately, and you're like, no, like, how did you forget that? But then when you're coding it live, you're just kind of like, eh. All right, cool. Cannot reshape an array of size 150804 into shape 150, 153. I'm going to actually cat a piece of code I wrote a long time ago to see what that was, just so I can verify what that resize was. cv2.resize. Okay, so there was actually a step there. Sorry, I'm peeking at some code I wrote earlier. It's code from a different project, but it does do the right
Code reuse
thing.
is an important thing.
Code reuse. So okay, we have cv2 resizing the image to the right dimensionality for us, and then we have numpy reshaping it into the proper array for what we're actually looking for. And that should actually be correct. The rest of this is roughly true. And I'm going to stop looking at my previous code now. Cool. So then let's go ahead and print these out and see what that looks like for us. 42 Force points out, code reuse works all the time. Yes, I am generally a big fan. All right, so we get these like just kind of random looking arrays. They don't look particularly meaningful. You get this is like a numpy data structure where you have an array and it has like a super listed in number. It's 1. The other one could be 0, but they're both 1. And then our D type is kind of a 32-bit integer. So that's not super meaningful to us, but if we actually just access the 0th element of the 0th element of each of those arrays, we'll just get the numbers back. And then what we can do is I'm actually going to also print out which image path that's associated with. So I'm going to say that image paths at I in enumerate of images.
And Kloppenberg says, we'll have to finish this later on. It's been a joy. Thanks, Colton Nick, for doing this.
Awesome.
It's been a good time. Gaston says, can I guys send you my CV so that you take a look? I built a great resume. Again, I don't believe CS50 is currently hiring or looking at CVs or resumes. Normally, when we do, we send out, we have an apply link set up, which is currently not accepting. But particularly if you're interested in working for a Silicon Valley company, I would do research into companies in that region, check out their website, check out their job applications, and then submit your CV there. You probably have much better luck doing so.
Yeah.
But thank you for offering to us, and definitely if we are hiring in the future, definitely submit it. And then Bavik Knight says 00 in brackets would do as well for numpy.
Yes, that is true. I think it also works for Python. I'm just generally a fan of kind of the old-fashioned way. I'm not that old, but I am certainly an old-fashioned user. All right, so I am still kind of copying things to speed things along a little bit, and then I will tell us what's going on. All right, so we can actually then go from here. All right, so we want to be able to map between the numbers and the actual classes that we're talking about, like light, dark, things like that. So we're going to say, nice. All right, Colton got called out for his great people skills. That's true. He does have fantastic people skills. I wanted to make sure that he didn't end up reading his own compliment.
Thanks, Ashley. Appreciate that.
He does a great job with people. All right, so we're going to define invert mapping. It's something that I think is just kind of useful. Given a dictionary, which I'm going to call D, we're going to have inverted, which is the inverted version of that dictionary. And I can say for key in D. And actually, you could say like key value in d.items. This might make it a little bit easier on us. Then we can say inverted at the value is equal to the key. And this assumes kind of a lot about your dictionary and how it works, but that's okay. We can actually prove that those assumptions are valid because of how Karis defines the class indices dictionary. But that basically allows us to switch it from, it gives you the index like name or the like label name with the number, and I want the number with the label name mapped to it. So I just invert the dictionary for us. There might actually even be a Python function that already exists for that. I just don't happen to know it.
And Bavik Knight has a dictionary comprehension suggested there in the chat.
Yeah, no, that's perfect. If you look in the chat, Bavik Knight's version of the dictionary inversion is exactly what I just wrote out, but in one line and certainly very readable. So very nice. Cool. So now that we have this kind of mapping, we can then just go through and for our prediction, or actually we're going to say the kind of, I think value is what I called it, value and im name in predictions, we can actually now print out what each of those things was. So we think that im name is val. Oops, sorry, not val, but rather mapping at val. Cool. And if we run this through, ooh, that's not what I wanted. That's what I wanted. If we run this through really quickly, then this will not actually build our model correctly. It's certainly not the right version of the model. It's not going to get things right. But what we are going to have is, at the very end, it'll print predictions on any image that's in our predict directory. And that's what we see at the very bottom here, is that it says we think that the dark1.jpg is light, and we think that light1.jpg is also light. So it got one of them right and not the other one, which is not super great
50%.
for us. 50%. But we know that if we train things a little bit longer, we can actually do a lot better.
For Sunlight says, Nick, old is gold.
I'm a huge fan. I also love that the old way of labeling global variables used to be by appending a G to them.
Yeah.
So that's actually, I don't know if you intended that, but it is certainly the greatest pun on that. All right, so what I promised at the beginning, I guess, hopefully you'll take on faith that if we increase the number of times that we train this and allow it to kind of run its full course, we could actually get this to a point where it is correctly predicting on light and dark images. However, I promised that we could do cartoon versus real images, and so let's actually set up that data. And we'll find that it's actually really easy. The way that we set up this structure, all we have to do is replace the image directory and then rerun our script, and that's it. And so what we're going to do is I'm going to call this image old, and then I'm going to just kind of copy it and create a new one. Oh, I can't paste it into its own location. Bummer. That's okay. And we're going to now create this new image, which still has predict, test, and train. It's going to have two different JPEGs in there. And in test, instead of having dark and light, it actually has cartoon and real.
Gaston says, like Swift 3, very interesting. We spoke about SQL last session. Hope that we can build a common platform and start talking programming. Yeah, Swift is a good idea. I'll maybe see around if anybody knows how to program in Swift and wants to maybe make a simple application on Stream. If you want to maybe read Twitch's last comment there.
All right, so Twitch Hello World says, thank you, this is so interesting. I heard that the later AI that triumphed over the initial program, which won over the human at Go, had not been trained by humans, rather simply given the rules games and left to train itself. Yes, that's reinforcement learning at its best. Is that a type of coding that is called AI as opposed to machine learning? How is it similar or different in terms of the coding? Thanks. So yeah, fantastic question, and something that is one of the greater confusions with how AI and machine learning are related. A lot of times AI utilizes machine learning practices in order to generate what looks like intelligence, and the goal is actually to simulate human intelligence. That is kind of the benchmark, give or take. And so what Twitch Hello World points out there, which is that the AI or AlphaGo that beat a human being at Go was not actually trained by humans and was just handed the rules and figured it out. That's really crazy. It's one of the most powerful versions of machine learning, or artificial intelligence, I think, is actually much more close to what you're actually going at there. And it's super cool that it was able to do that. That is like a completely different version.
A ton of games against itself, basbasically, and figured out like what led to a victory.
It kind of simulated it in its head and figured it out. And that's nuts. That's insane. There's this really cool version of that type of learning. It's similar. It's the Reinforcement and Unsupervised Learning Challenge by, I think, Microsoft, and they use Minecraft for it. So you actually build a Minecraft agent and have it compete with other agents to like survive. And that's something that is also on my list of projects for winter break, is to build my own Minecraft agent and see how I can do on that.
See if you beat out everyone else. Battle Royale.
Battle Royale. I'm a huge fan of building agents for online video games like PUBG, things like that. Also, we're going to just start dragging cartoon portraits of people onto our data list. Now, generally speaking, you want to be really careful when you're picking up human data because there are a lot of racist AIs out there. And that basically just means they were trained on data sets that weren't complete. These data sets did not have representations of all kinds of people, and that's really important. It's something I actually feel very strongly about. Making sure that people realize that you're kind of just doing bad science if you don't have a complete data set. So even in the worst case where I can't, I guess, help you from being racist, you should certainly be able to recognize that it's bad science to not have a complete data set. And in the best case, you realize that being racist is not ideal. And so you are also trying to obtain the real goal of being representative and inclusive of everyone that could possibly be using your device.
Well said. Puppyline HD says, halfway in the CS50 course, should I be able to understand all of that? Because I don't, and it's kind of frustrating.
I would argue certainly not. I think even if you were working on, like if you were all the way through CS50, I would argue that you shouldn't necessarily be able to just understand this right off the bat. And actually, yeah, I think it should kind of be a little bit frustrating. It certainly was for me when I began, and I know for a lot of people it is constantly very frustrating. So I think what I would advise, or my general advice for that is, yes, it's very frustrating at the beginning and kind of throughout, but looking back at what you can do now is a really good way to alleviate that frustration. So for me, when I went into CS50, that was my first time I'd ever coded. That was 2 years ago. We're, I guess, getting on 3.
Are you a junior now?
I am a junior, yeah. And so I actually took CS50 as my first ever CS class. I had never really coded before then. I had built kind of computers and things, and so there were some kind of we'll say roots for doing some computer stuff, but I had never actually written a line of code. And so I was very kind of lost, and I give a lot of credit to my TF at the time, actually, for helping me with how CS could be a big part of my life.
Who was your TF?
His name was Vic Jayaram, so if you're watching,
yes. Shout out to Vic.
Yeah, shout out to Vic.
I know Vic personally. I can't talk. But
no, he's a great guy.
Yeah,
I
cool.
still remember the sections that I was in with him, and he also was super willing to be like, yeah, it's hard, but you can do it. He was very encouraging in that sense, and I give him a lot of credit for kind of making me feel like I could actually go through and accomplish a lot in CS. And I mean, I've been teaching the class that he taught for 2 years now. So like that's very cool. And I was really excited about that. And I like to tell it to a lot of my students is that, you know, I started out not that far from where you are now. I really wasn't all that different. And I think that that can be really helpful, especially if you're sitting there and you're like, wow, you know, like this seems very complex, or it seems kind of absurd. It seems basically impossible for me to accomplish. That is certainly not the case. And it's not the case that I hope any CS people or any CS staff ever kind of propagate that opinion. I think that it is very important for people to realize that CS can be for anyone that wants to be in it. I think that it rewards people who have natural talent. That's true. Almost any field does. But it particularly will really reward people for putting in effort. And a lot of fields are like that too, where you will actually get a lot of rewards out of it for putting in real effort.
Yeah, and it doesn't, all these streams, they take a long time, and it's just a small fraction of the amount of time that it actually does take to do a lot of this stuff. It's time-consuming, but if you enjoy it and you put in the work, it's very rewarding.
Exactly.
And it's fun. It can be very fun.
Could not agree more.
Nick is not racist and loves puns. Great addition to the channel. Yes, I very much agree.
Thank you. I appreciate it.
What is the difference between React and Angular?
Oh, that's a good question.
So, unrelated to machine learning, but in a nutshell, they are both front-end frameworks for web development. They abstract what it means to do front-end development and make it a bit more modular and are more high-level. Tomorrow, we're actually going to be talking about React with Brian Yu, where we can maybe do a deeper dive into the differences and nuances between the two. But React is certainly the more popular presently, although Angular has been around for longer and has also had a lot of fame associated with it. Is it safe to study the same sort of coding in courses as machine learning to eventually execute unsupervised learning?
So let's see. Yes and no. Yes, in the sense that you need kind of the basic background and other information. Oh, sorry, ignore my desktop, it's a mess. You do need a lot of the same background and basic information and kind of practices that you see in kind of this supervised, rigorous learning that we're doing right now. But you also would be exposed to a lot of new techniques that people realized they could use when they didn't have to actually watch or give answers to the AI or their machine. There's also a lot of kind of different best practices in play. Like, I'm not really necessarily collecting data. I might be, kind of as was pointed out earlier, I might be pointing out rules. I might be looking for kind of patterns that are a little bit broader than the actual data that we're looking at. And that can be really important, especially if you're creating these like agents. Then you give them a set of rules and then you kind of see what they do. Or you might give them a set of rules, see what they do for a little bit, feed them some information as kind of like a response to what they did, and then let them go again. So there might be kind of interactions. Actually, I think a lot of the time there are interactions between this unsupervised learning and the supervised learning. So yes, you definitely would want, I think this is easier to start with. It's a little bit easier for us to contextualize. Excuse me. But you will learn a lot more in that field as well. There is a lot to that on its own. I think this is a good place to start, though. There are a bunch of questions.
What is the best technology that fits for a certain and guaranteed hiring? Honestly, that's a hard question to answer just because every industry is a little different. Every niche in every industry is a little bit different. I would say figure out what you want to do in computer science or whatever field you're interested in. Do a deep dive on it. Learn a lot. Spend a lot of time figuring out whether you enjoy it or not. And make some projects. Flesh out your GitHub a bit. Reach out to people, get some smaller jobs, see if their work experience is fulfilling, and sort of build upon it from there. But it's hard to frame it as there being any sort of magic bullet or magic trick, because at the end of the day, it's going to be a lot of hard work ultimately. Because if it was easy and free, everybody would do it, and everybody would have a very well-paying job in tech.
That's true.
So the reality is, you're going to have to spend a lot of time figuring that out for yourself and doing research and getting good at various technologies, and ultimately probably finding a specialization or a given strength in a particular field.
Yeah.
But good question.
Very, very good question.
For Sunlight says, this is the real power of teaching. Connection fuels commitment. I guess daily live streams will increase the commitment of students. I think so too, and I honestly hope that this channel helps inspire other people to dig into more projects of their own, and we get to build some really cool stuff on stream. I know today's has been really cool. It's been very unique relative to all the ones we've had so far, and very technical, which is nice. I like the deeper we can go into this stuff. I think it shows a little bit more of the reality of actually getting into the nuts and bolts of this kind of stuff.
Yeah, no, it's. I mean, I'm super excited that Colton asked me to come and join and be able to present with all you guys. But also, I think Colton's idea for just having a Twitch live stream, that's fantastic. I think that's super awesome for what you guys get to do, and you get to have just new topics all the time.
I get to come in and I not even have to prepare anything.
Right.
It's great. I can mess up live on stream, and everyone sees what it's like to be a real programmer. How about that?
Actually, that's a really important part of this. And Colton told me about it last week when I was kind of thinking about what to do for this, is that being able to mess up live on camera, that's great. I think it shows a lot of people just kind of the ridiculousness of the belief that people just are monolithic coders, right? Like they just come in and they just go boom, boom, boom. those coders, I guess, do exist, but they aren't necessarily. They're usually a product of having done it a lot. I mean, they've sat down and really fleshed this out. So having kind of, I guess, the live version of that going online and having that in front of you, that's really cool. And it's something that I wish you saw more in other fields too.
Yeah, a big trend is like making an app in 10 or 15 minutes, but
Right.
the reality is it's very unlikely that any actual app or project you make is going to take 15 minutes. But those videos are cool for introducing at least the concepts behind a lot of those things, like building the games and such. Gustin says, thank you, Colton. Hope to be friends on Facebook. Yep, send me a friend request. I'll accept it. Shout out to Colton. Live stream is cool. I'd like to see people get frustrated and break code like I do in peace as practice, etc. Yeah, that's going to happen. That's absolutely going to happen. Bavik, thank you for that.
All right, so as promised, a little bit behind schedule, but definitely as promised. I've edited kind of a little bit of our code. I added a command line argument so that we could modify things as we go. But we have just changed the entirety of what we're doing. We're no longer classifying between light and dark. We are classifying between real and cartoon pictures of people. And all we had to do was find new data sets and label them. That was it. And the code will work entirely fine on those. You'll notice things are a little bit harder here, where we still are validating things. Oh, nice. David.
Yeah, shout out to David for throwing my Facebook in the chat there. Prof is here. Welcome, David, sir.
Yep. Welcome back, David. And so this validation accuracy is not necessarily going straight to 100 anymore. It is a little bit difficult to classify really between cartoon images and real life ones. But you'll notice we're doing way better than just guessing. We are not at 50-50. We're at some 80% and 80%, which means we're roughly, not too terrible on this. That's the same bug I had last time. Let me get rid of that and let it run again. Remove image / predict /.ds. There we are. So annoying. I told you at the very beginning of the live stream that was going to come up, and I forgot about it.
It's like we've come full circle, kind of.
Yeah, we've come all the way back to what we had at the very beginning, where there was a small bug, we fixed it, and now we are doing what we kind of promised at the beginning. We are classifying between cartoon images of people and real images of people. And what that means is, I mean, in concept, you could train this a lot better with way more comprehensive data and doing all sorts of cool things. But even with very limited data sets, in like roughly 2-minute training times, and in an hour and a half, 2 hours of coding, we were able to get to a model that works pretty well on what's going on here. There's actually quite a few concepts that we demonstrate in this model. There's a lot of things going on underneath the hood, and which is one of David's actual favorite phrases, I think. What's the record? 40,
I think someone cut a video on our production staff of how many times David said under the hood, and it was a lot. It was a good number.
Funny.
A good number of it.
So yeah, there's all sorts of things going on in this even simple project, and I think that there's a lot of places for it to grow and expand. So you're welcome to take the code; it's all yours. There's no need to credit with me with it. And the images are not mine, except for the pictures of me. There is a picture of my face. I use it as the profile picture, and you'll notice even here we didn't do a great job of predicting. We guessed that they were both cartoons. One of them is certainly not a cartoon. I'm a real person, I swear.
It's debatable. That's
debatable. I'm certainly not a cartoon version of myself, I think. But yes, we basically were able to get from beginning to end in about 2 hours, and we have a machine learning model that allows you to predict on things. There's plenty of room to modify this to make it a little bit more general or to make it usable from the command line or as an app. But this is certainly I think if you were able to kind of get through this, even without fully understanding everything, even if you were just sitting there and kind of being like, oh, this is kind of cool, that's fantastic.
I mean, even I'll admit, awesome. I don't know every detail of what we talked about, but it's been fascinating and actually inspiring to go and dive a little bit deeper into these technologies and into machine learning. So I think if that's even what some people take away from this, they're like things, different fields, different niches of CS or other fields can be interesting or inspiring even without knowing all the details. Like that's great. That's how seeds are planted for future exploration.
Yeah, I thoroughly agree with that. Couldn't be better said.
Thank you very much, says DK Bixbomb. It has been instructive and very inspiring. Special thanks for the encouragement. Absolutely. No, it's been a great session.
Thank you. We appreciate having you guys sitting here talking with us. It's really cool.
The back and forth is what really makes this a ton of fun. 32 Force, many thanks for the effort, Colton and Nick, along with the rest of the CS50 team. This is something to be thankful for by being here in the 20th century. Education is now a free resource. Absolutely, no, and it changes every day. And special thanks to our production team for setting this up for us too. I mean, this is only possible because of their their hard work, and for David being in support of the vision as well. So shout outs to David and the production team. If you want to read, maybe you want to read off Twitch.
Sure. Yeah. So Twitch Hello World. Nice. We went for like 2 smaller ones and then.
Giving
nice.
you.
I appreciate it. That's cool.
It
So Twitch Hello World says, is the distinction between, say, a PhD in AI, for instance, those who develop the new techniques and or develop TensorFlow itself, as opposed to the MS, BS degree holders and self-trained as those that execute these techniques in various settings? I hear sometimes PhDs are overqualified for some openings, though it seems some companies prefer advanced degrees for their AI research. Thank you so much for this. So of course you're welcome. We appreciate it. But also that's a great question on like the difference between like PhD, MS versus BS. And actually a lot of that can vary by country. I know that in certain countries it's actually really common to get a BS, then an MS, then a PhD. In the United States, a lot of times you jump from BS to PhD. There's maybe some like years of research in between, but you actually just go straight from one to the other. And so it's a really good question for asking, like maybe what are companies looking for? And a lot of companies, especially like the big 5, you're looking at them and you might say, okay, well, I might want to go work for like DeepMind, Google DeepMind. They tend to look for a lot of PhDs. I don't know of too many people who are undergrads who are going to work on DeepMind. That's very cool. It's super technical work. And they tend to do a lot more theory before they put it into practice. But I think differentiating between like people who are purely theoretical and people who are purely practical is kind of a false dichotomy. There are people who are very theoretical who can do a lot of really cool practical stuff. They can build apps out of nowhere. And there are people who are super practical who also happen to know a lot of theory. And so I think that they go hand in hand. The more theory you know, I think it makes it a little bit easier to do things practically. There are some classic counterexamples to this, but I think in general that's true. And the more practical things you do, it motivates a lot of the theory. Why am I curious about how this actually works underneath the hood? Until I've done it. And then I see where things break. Now maybe when I understand how things work, I might say, oh, that makes a lot of sense. I can actually fix this now. And so it influences both directions.
We can answer questions like, what's a sigmoid?
Right. Right. Exactly.
What if we live in a cartoon, says Magus?
That would be really cool. Actually, there was a friend of mine who posed a really cool kind of thought experiment on that, which was, could you ever believe that we would be living in a matrix? And I'm going to just absolutely bungle this. But he said it really eloquently, which was like, if you could believe that we could ever be a matrix, then it's probably pretty possible that we're in one. Because if you think that AI could ever be like representative of a human being, then the fact that that could already exist would make us exactly where we are now. It would be not identifiable. And I think there's a very famous like discussion or set of quotations between Elon Musk and Stephen Hawking and talking about the probability that we live inside of a simulation. And that is, they say that it's really high. The probability that we don't live in a simulation is very low. And based on what we know, that's true. At least based on that topic and kind of my readings of the articles on that. However, a counter to that example is, let's say that I have a soccer team A and a soccer team B, and I say, what's the probability that soccer team A wins when they play together? And you would pretty reasonably, hopefully say, it's about 50%. And that's true. That's the current probability given what you know. However, if I tell you that soccer team A is Harvard's varsity boys soccer team, and soccer team B is my kindergarten soccer team, you now know that the probability that soccer team A wins is roughly 100. I would argue actually 100. I hope it's 100. So that changes entirely. Yeah, go Harvard. Yeah. So that's a crazy shift in what our probability is. It went from something that is literally probabilistic to something that is quite hopefully deterministic. And that, I think, points to a lot of these questions about, are we a cartoon? Are we in the matrix? Are we kind of in these sort of things? There are people who are very smart and very relevant to this sort of discussion, and they have a lot of cool opinions on it, but it's good to also temper those opinions with the reality of the probability that we know very much about our world and our universe even, pretty minimal. We don't even really know what's in the oceans. So to say that we might understand something about the universe is pretty limited to what we can actually say, given that the amount of information we know, the total kind of breadth of knowledge of humanity, pretty small. In kind of if you imagine that the breadth of knowledge that actually exists is infinitely larger, or almost infinitely larger.
We're into a metaphysical
conversation. Yeah, very metaphysical, very philosophical.
CS50, twitch.tv/CS50TV. Let's see, make sure we didn't miss anything.
Right.
Colton and Nick, you are amazing. Thank you for the great work you're doing. Thanks so much, Bella. Appreciate you coming in time and time again. I think we've seen you on every stream so far, so thanks so much.
That's awesome.
Thanks for the live stream, says Babik. I really enjoy being here. Glad to have you. Babik, also a regular. David's heading out. Thanks, David, for joining us on the chat. Got some thank yous for David there in the chat. Which IDE are you using, says Marlindo71.
Visual Studio Code. And I think Babik Knight actually answered that right below.
Oh, yes.
But yeah, I'm using VSC. It's one of my favorite IDEs. I also sometimes switch to Atom if I'm feeling kind of fun. But Yeah, whatever works for you.
How to choose the best partition after preparing a Genie or Shannon tree. How to identify the prediction exceptions. I can't say I know.
Okay, so I don't know super well what exactly Genie and Shannon trees are, though I would imagine that it's related to kind of forest decision problems in machine learning. And I can kind of explain a little bit of that. It's basically you pass a set of data into a set of, they're called like trees that make decisions. And at first they're random, and then they start to kind of really successfully choose based on decisions. And this goes iteratively all the way through. That's a very rough kind of leaving out a lot.
Excuse me. A decision tree pipeline almost?
Yeah, I would think of it kind of like that, and there's like some nuance that I'm pretty much omitting. And I believe if you're talking about something along those lines, then it's very similar in the decision to choose like a rectified linear unit versus a sigmoid versus like different activations in what we saw here in our linear models. And that's roughly what you end up seeing. But because I don't actually know what a Gini or Shannon tree is or are, I can't necessarily speak to how you would actually identify the prediction exceptions on those.
Cool. Cool. Thank you, says Twitch. Hello world. Asley says, if we lived in a cartoon, we could run in the air until we look down. That's
possibly,
like
yeah.
one of my biggest desires right there. VS Code. If you are looking for an IDE to do Python stuff, PyCharm is very good. I use PyCharm for Python. I haven't used it myself, but I've heard the same thing. Yeah, people tend to really enjoy it. Patrick Schmidt tends to really like that a lot.
Oh, that's awesome.
Love Professor Margot Seltzer's phrase, if you do good, you will do well. Yeah, yeah, do good, do well.
Yeah.
That's one phrase that she definitely says. It's very true, very true. Also relevant, we have a Reddit post here. I'm going to pull it up on my computer.
I was going to say, that's a dangerous...
Junk Bear, what is happening here? Okay, the number one data, maybe if you want to pull it up, it looks okay.
Oh,
pull it up on your web browser there.
Let's see. Twitch.
Oh, actually, oh yeah, you have to go to the chat, I guess.
Or CS50 TV?
Yeah, and then I'll paste it in there again when you're in the chat.
Yeah, yep. Gotta love the Wi-Fi. Anytime you like are actively observing the Wi-Fi, it's millions of times slower. But then if I like look away, it's gone. Look at that. Cool. Oh, this is gonna be pretty meta. You're gonna be watching the stream. Oh, well, you get an ad. Nah, just I was gonna say you're gonna be watching the stream.
Watching the stream within a stream, kind of.
Yeah,
kind of. I think the chat is. You think you have to expand that a little bit? There it should be there. So let's paste that bad boy right in there.
Beautiful. All right, so we get this beautiful gem. It almost looks like an XKCD comic. All right, so the number one data scientist excuse for legitimately slacking off.
Yeah, that's like the old my code's compiling joke from back when.
My favorite.
Back when programs took 30 minutes to an hour. I guess some probably still do take that long.
I believe so.
Probably much longer than that.
Yeah.
Things like I don't know about Chrome, but maybe like Microsoft products like Word and Excel. Those probably take ages, right? What is happening here, Drunk Bear? We are just recapping this is the conclusion to our machine learning stream here with Nick Wong, but it's going to be on YouTube. The VOD should be up on Twitch. We built a simple binary classifier, and then I guess this is a perfect way to sort of close it off too.
Yeah, I figured we can kind of loop all the way back around.
The visual of Nick's custom little shell screensaver here, which is really cool. I don't know if maybe you want to link to how you got that.
Yeah, actually, I can link to what that is.
That's really cool.
I can post that here. Well, let me log into Twitch.
Yeah, you're a genius, guys. Genie and Shannon's are algorithms to identify the best fitting model to adopt, so you can build a classifier. Yeah, it sounds like what you're sort of saying, yeah.
Okay, I can't log in. I can tell you what it is. It's CMatrix is the program that actually runs. I piped CMatrix into lolcat. So I can actually show you what that looks like.
Adam is a bit slow to start. I like Vim's key binding very much, so I use it inside the IDE, says Babbitt. Yeah, Adam is a bit slow. Try VS Code out, see if that's a little bit faster. I know it uses less memory than Adam does, but the two are, I believe, both built on Electron, so they both do use a bit more memory than they need to. Well, not that they need to, but that is compared to other IDEs or other text editors. Puppy Lion HD, when is the next stream? The next stream is tomorrow, so we'll have CS50's Brian Yu, our head teaching fellow, who'll be in here. Shout out to Brian. He'll be teaching us how to use React, the basics of React. And his web course is, I think I pasted it earlier, but just to do it one more time, he taught that course, a web course. So if you want to maybe glance over some of the course materials there. I don't recall offhand if he taught React in that class. I know that Jordan's class did teach React, React Native, which part of that was React. Recently installed VS Code. Oh, sorry. Did you put the thing in
I did. Sorry, I put the command up here. It's this command is technically what I run, or I guess this is the actual command.
Okay, so they need to install CMatrix and lolcat.
Yep.
And then once they have that, they can alias that in their bash profile, and then they're all set to go.
Yeah, and I like to call it rest because it's what I do when I'm resting, and I'm not actually teaching anything actively.
Love it. I love it. That's nice.
Cool.
We'll keep that on there for just a second.
Right,
but yeah, this was Nick Wong building a binary classifier, a humble introduction to machine learning. I didn't absorb probably more than 50 or 60% of it, but it's very inspiring.
Thank you.
It looks like a deep rabbit hole. It looks like
a
lot of very interesting stuff. a lot of fancy terminology that I would love to understand the theoretical meaning of. But machine learning powers so much of the modern world, so it's nice to get a glimpse into how it works.
Yeah, thank you for having me, Colton. I really appreciate it. It's been awesome.
No, it was a
looking forward to all the future talks we get to.
Terrific stream. And join us again next week. On next Friday, we'll have Nick talking to us about some of this fancy terminal stuff. He'll be showing us basic Linux commands. So a bit more of an entry-level stream. Some how do we use the command line? What are some common commands? Things like ls, cd. And maybe some other things like piping or however much time we have, which is a great foundation upon which we can build other streams and get people more fluent in using the command line. What password managers do you guys use? I keep forgetting to ask that. Davis talked about it in the cybersecurity lecture, but I'd like some recommendations to try. We use 1Password for CS50, so take a look at 1Password. I don't know if you use...
I use LastPass, but
they're all probably more or less identical or feature compatible. But yeah, using a password manager is a very handy tool.
I just get a student discount for LastPass. So.
Oh, nice. Okay, a little bit of a interest there. All right. Well, thanks so much, everybody. This has been CS50 on Twitch, our 7th episode, binary classifier with TensorFlow, Keras in Python. Thanks for everybody who's tuning in. As always, if you have suggestions, definitely let us know. We'll be joined again by Nick next week, and this week we'll be joined by Brian tomorrow for some React. And then on Friday, we'll take a look at some Unity. We'll make 3D Pong.
Nice. That's awesome.
So yeah, that'll be it. Any last things you'd like to bring up or
mention? Thank you, guys. Really appreciate it. I'll see you guys next Friday.
Cool. See you, everybody. Thanks so much again. Looking forward to the next stream.
Awesome.